Hello there and welcome to Life Beyond Seen, where curiosity finds a quiet rhythm and science drifts gently into the spaces of imagination. Tonight we're not looking up at the stars or out across the clock, but downward, into the sea, into the waters where sunlight begins to surrender. The place people call the Twilight Zone. It is not the world of television or mystery stories, but a real band of ocean hidden under the surface where the brightness we take for granted can no longer keep its hold. Above it there is warmth, colour and familiar life. But once you pass a certain depth, the sun is no longer in charge. There, another kind of life continues. Think of it for a moment. While you sit wherever you are, in your room or on your couch, maybe preparing to drift towards sleep, beneath the oceans the planet keeps its quiet secret. Billions of creatures go about their lives in the dim half-light, a perpetual dusk that never ends. It is strange, isn't it, to know that while we rest in a cycle of day and night, they live in a place that has no real day at all. Just a slow fade into blue, then darkness, then nothing but the faintest glimmers made not by the sun but by the animals themselves. Have you ever wondered about that? About what happens far beneath the waves when the sunlight fails? Perhaps when you've stood by the shore or flown over the ocean and seen only the surface, you thought of how endless it looks. But it hides something deeper, stranger, and more alien than most of us realise. If you've ever swum in deep water and felt that faint chill even on a bright day, you've touched the beginning of that realm. Before we sink any further into this exploration, let me pause here to invite you, gently, to stay with us on these journeys. If you find this sort of calm curiosity helps you relax or keeps your mind company as the hours slip by, I would be grateful if you gave the video a like, maybe even subscribed, so that this little corner can find others who could use it. It is a small thing, but it helps us keep going, just like the faint traces of light that reach into the sea. So now let's begin our slow descent. Imagine the surface behind you, the warmth of daylight fading away as you sink deeper. The blue darkens around you, pressure builds, and the sound grows quieter. There is still life here, but it changes. We are crossing the border into the twilight, a place of fading colours and growing mysteries. At first, the change is subtle. The surface light still reaches in scattered beams. The water looks blue but darker than you expect. Swim down a little farther and red disappears. The colour of blood, flowers, apples, sunsets, all of it is swallowed quickly. Soon orange is gone too, then yellow until green and blue alone remain. Every few metres deeper, another shade vanishes until the world becomes stripped of everything we normally use to recognise it. If you wore a red shirt here, it would look black. If a fish bled, its blood would seem dark as ink. This fading of colour is the start of a different set of rules, the rules of the Twilight Zone. Scientists often call this layer the mesopelagic zone. It stretches from around 200 metres below the surface to about 1,000 metres. That may not sound like much, but when you picture 1,000 metres of water, imagine stacking 3 Eiffel Towers one on top of another and still not breaking through. It is more space than all the forests on Earth combined, yet it lies almost entirely unseen. No sunlight strong enough for plants to grow can reach here. There are no kelp forests or coral reefs. Energy comes from above in small drifting pieces, or from the bodies of those who travel up and down each day. As you sink into this band, pressure multiplies quickly. At 200 metres, it is already 20 times what you feel at the surface. At 1,000 metres, it is 100 times greater. That's like having the weight of a car pressing on every square inch of your body. It is unimaginable for us. Yet for the creatures who live here, this is home. Their bodies bend, flex and flow in ways ours never could. Bones are rare. Many are soft, gelatinous, almost transparent. For them, resistance would be dangerous. Flexibility means survival. The water is cold, nearly freezing, and yet there is no ice. The constant mixing of currents brings down oxygen and carries away heat, but not enough to make it unlivable. In this darkness, life has found ways to adapt that are so unusual they feel like something from another world. It is easy to think of this realm as empty. For a long time, people assumed it was. Fishermen dragged nets and found almost nothing. Early divers never went deep enough. Even today, we have seen only a fraction of it with cameras and submersibles. But scientists now believe the Twilight Zone may be one of the most populated parts of the planet. Some even suggest that the sheer number of fish here could outweigh everything caught on the surface. Imagine billions upon billions of silver bodies drifting in the dark, moving together like rivers within the ocean. What survives here must deal with a peculiar problem. There is almost no light, but still just enough that predators could see if they adjust. So animals adapt by becoming invisible in different ways. Some are transparent, their bodies like glass, letting what little light there is pass straight through. Others are coloured in deep reds and blacks, shades that disappear quickly in dim water. Some even carry their own lights, tiny organs called photophores that glow softly in patterns like stars. To us it seems like magic. To them it is a tool for survival, for hunting, for hiding, even for attracting mates. We will meet these creatures soon enough, but for now, feel the setting. The water around you is hushed. The temperature drops to near freezing, yet life pulses faintly all around. Shapes drift by, some ghost-like, some flashing with pinpricks of blue or green. It's not the emptiness once imagined, but a hidden metropolis spread through miles of darkening sea. And as we continue this slow journey downward, you might notice something peculiar. Just as time feels different when you're waiting or when you're absorbed, space feels different here too. Distances stretch. A kilometre in the open air is a short drive, but a kilometre downward in the sea feels endless. Each metre brings heavier pressure, stranger life, and deeper quiet. The Twilight Zone stretches wide, yet it seems to press close, like being inside a great blue cave. This is where our story begins, at the border between day and night, a part of the ocean that is neither fully lit nor completely dark. A place where sunlight ends, but survival does not. The ocean is not divided by walls or doors, yet when you sink past the surface, you begin to feel boundaries that have no physical lines. The edge of light is one of those boundaries. At the surface, the sun rules. Even on cloudy days, its glow floods the shallows. Fish shimmer in bright colours, corals bloom in impossible shapes, seaweed grows tall like forests reaching upward. But as you slip deeper, the grip of the sun begins to loosen. At first, you hardly notice. The colours simply look a little duller. Then, metre by metre, they fade until what once seemed full of life becomes muted, like a painting losing its pigment. This is not yet total darkness, but it is a clear border between worlds. Scientists often measure this border around 200 metres beneath the surface, but it shifts depending on the clarity of the water and the angle of the sun. In the tropics on a bright day, light may push a little deeper. In murkier seas or at higher latitudes, it may fade sooner. But on average, around 200 metres down, photosynthesis can no longer function. Plants need light to grow, and past this point, they can't survive. That is why coral reefs vanish and kelp forests stop. This is the end of the green world. Below it lies a new kind of ocean, ruled not by growth, but by endurance. The edge of light has no effect on the creatures that live nearby. Some hover just above it, feeding on the last traces of plankton that still grow where light lingers. Others drift just below, using the dim background to hide themselves. For animals that move up and down through the water each day, this zone is like a highway. They travel upward at night to feed near the surface and return by day to hide in the shadows. These daily migrations, called DL vertical migrations, are the largest movement of life on the planet. Billions of fish, squid, shrimp, and other creatures rise together, invisible to most of us, then retreat back to the edge of light as the sun returns. It is as though the ocean breathes each day, inhaling life upward at night, exhaling it back down by morning. When you picture the edge of light, imagine standing in a room at sunset when the last rays stream through the window. You can still see shapes, but their colours are washed out, their edges uncertain. That is what the Twilight Zone looks like, except here the sunset never ends. It is permanent dusk. The difference is that in the sea, dusk is not peaceful silence. It is full of motion. Tiny organisms called zooplankton drift upward, chased by small fish. Those fish are hunted by larger predators, who in turn are followed by squid and deep-diving mammals. The edge of light is a border but also a battlefield, crowded with activity invisible from above. Pressure at this depth is already significant. Around 20 times that of the surface presses against every body, every shell, every gill. Animals that live here have adapted in clever ways. Many have soft bodies with very little bone, so the pressure does not crush them. Others have flexible proteins that keep their enzymes working in cold, heavy water. Even fish that look delicate are tougher than they appear, shaped by countless generations to survive a place most land creatures could not endure for even a moment. One of the most fascinating things about this border is how it changes with the time of day. At noon, when the sun is highest, the edge of light feels sharp. Everything below is dim and cold, everything above is bright. But at dawn and dusk that line blurs. Shadows stretch deeper, light filters farther. Animals sense this change and adjust their behaviour. Predators may strike more often in the confusion, while prey tries to hide in shifting beams. The cycle of light and dark above continues to dictate life even down here, at the edge where the sun has little power left. Divers rarely experience this depth directly. Recreational diving usually stops well before 40 metres, far above the Twilight Zone. Beyond that, the risks increase quickly. Nitrogen narcosis, oxygen toxicity, and the sheer difficulty of surviving under such pressure. To truly see the edge of light, people rely on submarines or remotely operated vehicles. These machines carry lights and cameras that reveal what human eyes cannot, but even they alter the environment. When a submersible shines its beams into the gloom, animals scatter or behave differently. The true twilight, undisturbed, remains mostly hidden. Yet what glimpses we have are extraordinary. Lanternfish with shimmering bodies form immense schools, their silver sides catching what little light remains. Hatchetfish glide through the water, their flattened shapes reflecting beams in ways that make them vanish almost completely. Tiny shrimp drift like sparks, and jellyfish pulse with faint bioluminescence, their bodies delicate as smoke. These are not the vivid reefs of shallow seas, but the subdued beauty of creatures that live by stealth and endurance. The edge of light is also a place of trade. Above it, energy from the sun drives the growth of plankton. Below it, animals must rely on what drifts down. Marine snow, the slow fall of organic particles from the surface, becomes food for countless creatures. Tiny bits of algae, waste and remains sink through the water column, drifting past the edge of light like ash falling through air. It may seem small, but over time it sustains entire populations. Some animals wait here, feeding on this rain as it passes. Others follow it downward, drifting with the snow into darker waters. Humans are drawn to edges. We like coastlines, horizons, the places where one thing becomes another. The edge of light is one of the most dramatic of these natural borders. It separates the world we know from a realm we can barely imagine. Above is sunlit ocean, full of swimmers, surfers and coral gardens. Below is a silent world of dusk where creatures live in ways almost unthinkable to us. The thin layer between is a reminder of how quickly conditions change, how fragile the balance of light and life can be. It is remarkable to realise that most of the Earth's oceans belong not to the sunlit surface but to this dim and darker space. The Twilight Zone covers an immense volume, larger than all the land habitats combined, yet it remains largely unexplored. Scientists estimate that only a small fraction of species here have been described. Many more wait, drifting unseen, hiding at the edge of light, part of a living world we barely understand. When you imagine sinking into this zone, picture yourself watching as the last beams of daylight fade above. They bend and scatter, unable to penetrate deeper. Around you, the water glows faintly blue, but the glow is weak, like the memory of light rather than light itself. Shapes move in the distance, some rising, some falling. You hear nothing but the faint hum of water pressing against you, and for a moment you understand what it means to leave the human world behind. This is the border, the threshold, the edge of light where survival takes on forms as strange as any dream. But even here, where sunlight dies, life does not stop. It adapts, it invents, it glows. And as we continue sinking, leaving the edge behind, the world will only grow stranger. When we speak about the twilight zone of the sea, it's easy to imagine a neat band stretching from one depth to another, tidy and precise, as if the ocean had invisible markings like levels on a ruler. In reality, the ocean is far less exact. The question of how deep twilight reaches depends on many things: the angle of the sun above, the clarity of the water, the currents carrying particles, even the latitude where you are. Still, scientists place boundaries to make sense of it, and most agree that the twilight zone begins around 200 meters below the surface and extends down to about 1,000. That may sound like just numbers, but they represent a colossal span of water, a volume so enormous it defies easy imagination. 200 meters below the sea is already well beyond the reach of ordinary divers. If you've ever stood at the bottom of a swimming pool, maybe 3 or 4 meters deep, and looked up, you know how heavy even that little layer of water can feel, how muffled and strange everything seems. Multiply that by 50, then add the shifting darkness, and you begin to sense what the upper edge of the twilight zone feels like. At that point, sunlight is still visible, but faint, scattered into blue shadows. Fish still swim with colours, but they are muted, fading with every extra metre. By the time you drift to 300 metres, red is gone entirely, orange has disappeared and yellow is vanishing too. By 400, green begins to slip away, leaving only blue and violet light, the last survivors of the spectrum. By 600 metres, the human eye struggles to see anything without artificial aid. Shapes are dim, outlines uncertain, and most animals appear in shades of grey or black. Yet for creatures adapted to this dimness, the world is not quite dark. Many have oversized eyes that capture what little light remains, turning faint glimmers into usable vision. Others rely less on sight and more on vibration, smell, or the faint glow of bioluminescence from other animals. What feels like near blindness to us is, for them, a world rich with signals. At 1,000 meters, sunlight fails completely. Beyond that, the midnight zone begins, a realm of perpetual darkness where no ray of the sun can ever reach. That line at 1,000 meters is often treated as the true bottom of twilight, the point where dusk ends and night takes over. But it isn't a hard line. Some animals carry light deeper with them. Some particles reflect faint beams farther down. Depending on the season and the water, twilight may stretch a little deeper or cut off sooner. It is less a sharp border and more a gradual dimming, like a sunset that never finishes. To picture the sheer scale of this depth, consider the tallest buildings on land. The Burj Khalifa in Dubai is just under 1 kilometre high. Imagine lowering that entire tower into the sea, and at its base you would barely have reached the bottom of the twilight zone. The Empire State Building would vanish somewhere in the upper third. Mount Everest, if placed upside down into the ocean, would pierce through the twilight zone and into midnight beyond. These comparisons are imperfect, but they give a sense of how vast this layer of the ocean truly is. It is not a narrow strip, but an immense volume covering most of Earth's habitable space. One reason this depth matters so much is that it shapes the kind of life that can survive here. Plants and algae cannot live below the upper edge, because photosynthesis requires sunlight. That means the food web below 200 meters depends almost entirely on what drifts down from above. Tiny particles of plankton, waste from surface creatures, the bodies of animals that die and sink. All of these make up the slow rain scientists call marine snow. Without it, life in the Twilight Zone would not survive. Some animals have become experts at catching it, filtering the water for these small flakes. Others hunt those who drift upward to feed. In this way, the depth of twilight becomes not just a measurement of distance, but a force that governs how energy flows through the sea. Depth also influences behaviour. Many twilight creatures move up and down each day in search of food. At night, when surface waters grow dark, they rise to feed on plankton that bloom near the top. At dawn, as the sun returns, they sink back into deeper shadows to hide. This migration, from hundreds of meters down to near the surface and back again, is the largest daily movement of biomass on the planet. To us it is invisible, but for the ocean it is as regular as a heartbeat. It moves carbon, energy and nutrients up and down, linking the sunlit ocean with the dark depths below. Without this vertical commuting, the balance of life on Earth would shift dramatically. Pressure becomes another defining element as twilight deepens. At 200 meters, the pressure is about 20 times greater than at the surface. At 1,000, it is 100 times greater. That means every square inch of a body here bears the weight of an entire adult human pressing against it. For creatures adapted to it, this is normal. For us, it is almost unimaginable. Submarines that descend to these depths must be built with thick steel or titanium hulls, designed to resist crushing forces. Even small cracks can be fatal, yet the delicate bodies of fish and jellies manage it with grace. They survive not by resisting pressure, but by yielding to it. With no air-filled cavities to collapse, they flow with the water rather than against it. Temperature changes too. The sunlit ocean above may feel warm, but below 200 meters the water quickly cools. By 500 meters, it is near freezing, hovering just above 0 degrees Celsius. Few places on Earth are colder, yet life thrives here. Proteins inside cells adapt to work in low temperatures, membranes remain flexible, and enzymes function slowly but steadily. The cold slows metabolism, meaning animals often move sluggishly, conserving energy, waiting for food to drift down or for night to bring them closer to the surface. The depth of twilight also varies by geography. In clear tropical waters, light may penetrate slightly deeper, extending the zone past 1,000 meters. In turbid coastal waters filled with sediments or plankton, twilight may fade out much sooner, ending at only a few hundred meters. Polar regions add another layer of variation, with seasonal ice cover and long periods of darkness altering the way light enters the water. The Twilight Zone is global, but it does not look the same everywhere. Each ocean basin, each coastline, offers its own version of dusk. Exploring these depths is a challenge for humans. Even the best divers with specialised equipment rarely pass 400 meters, far shallower than the bottom of Twilight. To go deeper requires submersibles, remotely operated vehicles, or autonomous robots designed to withstand immense pressure. These machines give us glimpses, but the vast majority of the Twilight Zone remains unseen. In fact, some scientists estimate that less than 5% of it has been directly observed. That means 95% of this immense habitat is still unknown. For all our satellites and technologies, the deep sea remains one of the least explored regions of our planet. Yet we know enough to understand its importance. The Twilight Zone holds immense numbers of fish, more than in all the surface fisheries combined. Lanternfish alone may account for billions of tons of biomass. These creatures play a crucial role in cycling carbon, taking it from the surface and moving it deeper, where it can remain for centuries. In a world grappling with climate change, the Twilight Zone is not just a curiosity. It is a vital part of the Earth system, regulating how carbon moves between atmosphere and ocean, how heat is stored, and how ecosystems above and below remain balanced. It is easy to dismiss depth as just numbers on a chart, but when you pause to imagine what those numbers mean, they gain weight. 200 meters is the end of light. 1,000 meters is the end of twilight. Between them lies a world larger than all the continents combined, a realm filled with creatures we barely know, a place that sustains the balance of the planet. That is how deep twilight reaches, and yet it is not only about meters or kilometers. It is about the transformation that happens when light fails, when colour fades, when life learns to survive in conditions most of us cannot imagine. So, as we continue sinking into this strange ocean dusk, remember that twilight is not just a word for sunset. It is a vast living world, hidden in plain sight beneath the waves, stretching deeper than mountains are tall, holding mysteries that science has only begun to uncover. And as we drift toward the heart of it, the changes will only grow sharper, stranger, and more revealing. The deeper you sink into the ocean, the more the familiar spectrum of colours begins to betray you. On land, we think of colour as something solid, reliable, always present in the world around us. A red shirt stays red in sunlight or shade. A yellow flower still looks yellow whether you see it at dawn or noon. But in the sea, light is not evenly distributed. Water eats colours one by one, and the farther you go, the emptier the spectrum becomes until the palette of the world is stripped almost bare. It begins with red. At only a few meters below the surface, the longest wavelengths of light are already struggling. Red is vibrant in air, but in water it is absorbed quickly. Within 10 meters, it weakens dramatically, and by 20 it is nearly gone. That means a fish bleeding at this depth does not spill bright crimson into the sea. Instead, its blood appears as a dull, dark shadow. For predators, this is useful. Wounds or markings that would be glaringly obvious near the surface become invisible. Many animals take advantage of this fact by wearing red skin. To us, in shallow tanks or under bright lights, these fish appear fiery and dramatic. In their real home, they are cloaked in black, hidden from sight. Orange is next to vanish. Slightly shorter in wavelength, but still long enough to fade quickly, orange disappears within 30 to 40 meters. Then yellow follows, swallowed by the water by around 50 to 60 meters. Green hangs on a little longer, but by 100 meters it too begins to dull, replaced by deeper shades of teal and finally blue. Blue light, with its short wavelength, penetrates farthest. That is why the ocean looks blue to us when we stand above it. It is the only colour strong enough to survive hundreds of meters down. Violet lasts nearly as long, but it is faint and easily lost to the eye. What remains in the twilight zone is mostly blue and violet light, stretched thin, scattered by particles, never strong enough to illuminate clearly. For humans, this means the world below becomes a monotone place. A diver descending without artificial lights will notice colours vanish in order, as if someone is turning them off one by one. Red corals turn black, orange fish become shadows, yellow fins fade to grey, until almost everything looks washed out and strange. When lights are switched on from a submersible, the colours reappear suddenly, shocking in their vibrancy. What seemed dull a moment before reveals itself as painted in brilliant reds and oranges. This trick of light reminds us that the colours never vanish from the animals themselves. They are still there. It is only our ability to see them that fails. For marine life, this shift has profound consequences. Animals use the absence of certain colours to their advantage. Many small shrimp, crabs and fish in the twilight zone are bright red or orange. To human eyes in an aquarium, they glow like fire, but in their natural depth they are invisible, as effective as wearing camouflage. Some species are transparent instead, allowing light to pass through them without reflection. Others develop shimmering silver sides, which act like mirrors, bouncing back whatever faint light is present and blending them into the background. Still others choose black, the simplest solution, absorbing what little light there is and erasing themselves from sight. Predators adapt in response. Some twilight hunters have enormous eyes, designed to gather even the faintest traces of colour. Others develop sensitivity to wavelengths humans cannot easily detect. Certain fish can sense polarised light, giving them an edge in spotting prey that would otherwise vanish. It becomes a contest of perception, a silent arms race of visibility and invisibility. The disappearance of colours sets the rules for survival. One of the most striking examples of this is the use of bioluminescence. When natural sunlight fades, animals create their own light. Photophores, tiny organs filled with light-producing chemicals, glow in blues and greens that can be seen at great distances in the twilight gloom. A lanternfish might shimmer with faint dots along its belly, confusing predators or signalling to mates. A jellyfish might pulse with soft radiance, deterring attackers or startling prey. Some squid can control patterns of light across their bodies, flashing like underwater billboards. The colours that disappear from sunlight re-emerge in the bodies of animals themselves, but always in the wavelengths that travel farthest, blue and green. It is no coincidence. These are the only colours that carry across the twilight sea. There are stories of submarines drifting through the deep and suddenly finding themselves surrounded by showers of living sparks. Whole schools of creatures flashing in unison, as if stars had fallen into the sea. For the crew inside, it is like floating through a galaxy. For the animals, it is daily life, built on an entirely different palette from our own. The fading of colours also influences how we perceive time and place underwater. A diver who watches red vanish quickly can feel unmoored, as though the ocean is stripping away something essential. By the time blue alone remains, it feels like being inside an endless monochrome photograph. The lack of familiar shades changes mood, perception, even memory. That is one reason why footage from deep-sea expeditions often looks dreamlike. It is not that the cameras distort reality. It is that reality there is genuinely stripped of colour in ways our brains are not used to processing. Some scientists believe that the disappearance of colour has shaped not just the biology of twilight creatures but also the evolution of marine ecosystems as a whole. Coral reefs exist only in shallow sunlit waters because corals rely on symbiotic algae that need light. Seaweeds thrive near the surface where green and yellow wavelengths remain. But below, where red and orange are gone, different systems take over. Predators rely more on shape and movement than on colour. Prey adapt by becoming transparent or dark. Food webs rely less on photosynthesis and more on falling detritus. All of this stems from the simple physics of light absorption, from the way water swallows colours step by step. The psychological effect of this fading is worth pausing on. Humans evolved in a world full of colour. Our eyes are tuned to detect reds, greens and blues, and our cultures are filled with meanings tied to colour. Red means danger or passion. Green signals life. Blue suggests calm or distance. Underwater, those associations collapse. Red is invisible, green is fleeting, and blue dominates everything. To us it can feel alien, as if we've stepped into another planet. For the creatures that live here, though, this is normal. To them, the absence of colour is not loss but simply the natural state of things. It is tempting to think of the disappearance of colours as emptiness, but it also creates opportunities. Camouflage strategies only work because of it. Bioluminescence shines so brilliantly because of it. The Twilight Zone becomes a place where colour is not constant but negotiable, something that can vanish or appear depending on the eye, the depth, or the light. It is a reminder that what we see is only one version of reality, one way of interpreting the world. Imagine yourself drifting at 400 meters, light dim around you, colours almost gone. You look down and see only a blue-black haze. Then, out of nowhere, a flicker of green light appears, then another, until dozens surround you. Tiny creatures glowing, pulsing, fading. In the absence of natural colour, these signals become everything. They are communication, defence and beauty all in one. For the Twilight Zone, this is the real spectrum, alive not in the sun but in the bodies of its residents. And so, as the colours of daylight vanish one by one, a new kind of vision takes over. It is not the spectrum we know from the surface, but one rebuilt by life itself. Where sunlight ends, colour does not die. It transforms, shifting from the surface palette to the palette of survival, a spectrum of shadow and glow. As we sink deeper still, pressure mounts, temperature drops, and the last traces of sunlight thin out. Ahead lies a world where darkness is nearly complete, where the rules of existence are rewritten once more, and where survival depends less on what you see and more on how you endure. As the light fades, another force begins to press itself into every part of the body. Pressure in the ocean is relentless, and unlike light, which disappears gradually, pressure builds steadily with every metre. At the surface, the atmosphere itself weighs down on us, about 1 kilogram pressing on every square centimetre of our skin. We don't notice it because we've evolved with it, and our bodies balance it with the air inside our lungs and the fluids within us. But water is heavier than air. Every 10 metres down, the pressure increases by another atmosphere, another layer of weight pressing from all directions. By the time you reach 100 metres, the force is 10 times stronger than what you feel on land. At 200 metres, where the twilight begins, it is already 20 times stronger. By the bottom of this zone, near 1,000 metres, the pressure is 100 times what you experience at the surface. It is the weight of an elephant pressing down on every square centimetre, not from above, but from all around. Humans are not built for this. Our bodies contain air pockets in our lungs, sinuses, and ears. As pressure increases, these spaces compress, painfully at first and fatally if pushed too far. Even with special gas mixtures and careful decompression schedules, the human body cannot survive the crushing force of extreme depth for long. Submarines and remotely operated vehicles must be engineered with thick steel or titanium walls, carefully shaped to distribute the stress. Even so, they can only venture safely within limits. A single flaw in the hull could lead to instant catastrophe. Pressure at these depths is not forgiving. Yet for the animals that live here, this is normal. They are not crushed because they have adapted in ways very different from us. Most twilight creatures have no rigid bones or air-filled cavities. Their bodies are soft, gelatinous, flexible. Some are nearly transparent with muscles and tissues that bend and yield under pressure instead of resisting it. Without air spaces to collapse, they move with the water rather than against it. Others have special proteins and enzymes that remain stable under high pressure, allowing their cells to function when ours would fail. One striking example is the lanternfish, among the most numerous residents of the Twilight Zone. Their bodies are small and flexible, built for withstanding changes in depth as they migrate up and down each day. Squid too are masters of pressure resistance. Their soft tissues allow them to move freely even as the weight multiplies around them. Jellyfish drift gracefully, their delicate bells swaying as if unaware of the crushing force. What would be instant destruction for us is daily life for them. Pressure also shapes behaviour. Some fish rise at night toward the surface where pressure is lower, then sink back down by day. This constant movement subjects them to dramatic shifts, yet their bodies adjust easily. They lack swim bladders, the air-filled organs many surface fish use to control buoyancy. Instead, they rely on oil-filled sacs, gelatinous tissues, or simply neutral density to maintain their place in the water. Without air to compress, they avoid the dangerous ruptures that would strike other species during rapid depth changes. The power of pressure is not only biological but also geological. In the twilight and deeper zones, sediments settle differently, gases dissolve more fully, and chemical reactions occur under conditions alien to the surface. Methane hydrates, for example, form under high pressure and low temperature, creating ice-like crystals of gas and water that can remain stable only in these depths. The ocean floor at these levels is shaped not just by currents and erosion, but by the weight pressing constantly from above. For humans exploring these waters, pressure remains one of the greatest challenges. The first deep-sea submersibles were built like steel spheres, their rounded shapes designed to distribute stress evenly. Even with modern technology, reaching beyond 1,000 meters requires extreme care. Windows are tiny, often made of thick acrylic domes, and the hulls must be inspected constantly for signs of fatigue. At greater depths, even sound behaves differently under pressure, travelling faster and farther, making communication both easier and more confusing. One fascinating aspect of pressure is how it influences sound in the ocean. Because water transmits sound more efficiently than air, and because pressure changes the density of the medium, noises travel long distances. Whale calls, ship engines, and even distant earthquakes can be heard for hundreds of kilometres. In the Twilight Zone, this means animals live in a world where sound carries much farther than sight. Many species use vibrations to sense predators or prey, relying on pressure itself to send signals through the water. Pressure also affects gas exchange. At the surface, oxygen dissolves into water and supports marine life. But as pressure increases, the behaviour of gases changes. Oxygen levels in the Twilight Zone can vary widely, with some regions forming oxygen minimum layers, where concentrations drop dangerously low. Animals living here adapt by slowing their metabolism, reducing their need for oxygen, or developing hemoglobins that bind it more tightly. For us, such conditions would be suffocating. For them, it is another part of survival in a world defined by weight and scarcity. It is tempting to think of pressure as purely destructive, something that crushes and kills, but in truth, it also stabilizes. High pressure can keep delicate proteins from unraveling, prevent gases from escaping, and maintain chemical balances that would fail in lower conditions. For many Twilight creatures, pressure is not an enemy, but a constant partner, as natural to them as gravity is to us. They do not resist it. They are built with it in mind. The fascination humans feel toward pressure often shows in our stories of exploration. From early pearl divers risking their lives in shallow depths, to modern submariners descending into the abyss. The struggle against pressure defines our relationship with the deep. It is the invisible barrier that keeps most of the ocean hidden from us, a reminder that Earth is not fully ours. Most of the planet's volume exists under conditions we cannot endure without machines. Pressure guards it like a gatekeeper, allowing only those prepared to enter. And yet, every time we send a probe or a submersible down, we are reminded of the resilience of life. Creatures with bodies softer than jelly survive what would crush steel. Fish no longer than a finger thrive where submarines dare not linger. Pressure, instead of erasing life, has shaped it into forms both delicate and strong. It is a lesson in adaptation, in the endless capacity of organisms to adjust to the most extreme environments. The deeper you imagine sinking, the more you feel this force. At 200 meters, your ears ache, your chest tightens. At 500 meters, without protection, you would be gone in moments. At 1,000 meters, the pressure is so absolute it is hard even to picture. Yet for the Twilight Zone, this is simply the baseline. Farther below, in the Midnight Zone and beyond, the weight only increases until even our toughest machines are pushed to their limits. Still, pressure is not only about numbers, it is about the way life has answered it. The Twilight Zone teaches us that existence can flourish, not by fighting against impossible forces, but by bending with them, reshaping itself to fit conditions that would seem unbearable. It is another reminder of how alien the ocean can be, and how much of life exists beyond our ordinary sense of what is possible. As we leave the weight of pressure in mind and continue downward, we find that cold becomes just as defining. Temperature falls with depth, stripping warmth as surely as water stripped colour. Ahead lies a realm where chill is constant, where survival means finding ways to live in near-freezing water, and where the twilight turns ever darker. The deeper you go, the more the ocean reveals another invisible challenge. Beyond the fading colours and the growing pressure lies the steady theft of heat. Warmth is one of the most fundamental conditions of life on the surface. We live by the sun's energy, and even in winter its rays keep Earth's skin above freezing in most places. But water has a different relationship with heat. It carries it away quickly, spreads it evenly, and the deeper you sink, the less of it remains. In the twilight zone, cold becomes as permanent as pressure. At the surface, tropical seas can feel almost like a bath, warm and inviting, with temperatures above 25 degrees Celsius. But drop below 100 meters, and that comfort disappears. The warmth of the sun is shallow. By the time you descend 200 meters, the beginning of twilight, the water is already far colder, often less than 10 degrees. Descend further, and the thermometer continues to fall. At 500 meters, it hovers just above 4 degrees Celsius, a chill that never lifts. By the bottom of the twilight zone, near 1,000 meters, the water approaches freezing, 2 or 3 degrees, and it stays that way in almost every ocean on Earth. Unlike pressure, which rises with depth, cold levels off. It does not keep dropping forever, but it stabilizes into a near constant chill that defines the deep. For humans, this kind of cold is lethal. Exposed skin in water that cold loses heat more than 20 times faster than in air. Even with a wetsuit, survival is measured in minutes. With specialized dry suits and heated systems, divers can endure longer, but not at these depths, not with the pressure that comes alongside. Submarines and remotely operated vehicles must be insulated to protect their electronics and to keep crews alive. For most of history, such cold was an impassable wall, as dangerous as the crushing pressure above it. Yet, as always, life finds ways to adapt. The animals of the Twilight Zone do not fight the cold with insulation or heat. They adjust their chemistry. Proteins and enzymes inside their bodies are shaped to function at low temperatures. Cell membranes remain flexible even when chilled, allowing nutrients to pass through and energy to flow. Some creatures slow their metabolism so drastically that they move as if in slow motion, conserving every calorie, every pulse of energy, because in the cold nothing comes quickly. Others develop antifreeze-like compounds that keep their tissues from forming damaging ice crystals. These solutions are subtle, built at the molecular level, invisible to the eye but essential to survival. The cold also changes how animals behave. Movement is sluggish, deliberate, efficient. Predators strike carefully, conserving energy, waiting for the right moment. Prey avoid unnecessary effort, drifting with currents rather than swimming against them. Even the great daily migrations that carry animals up and down through the water are shaped by cold. Rising toward the surface at night brings not only food, but also brief relief in slightly warmer water. Sinking back down by day means retreating into chill that slows metabolism, saving energy until the next chance to feed. One of the most fascinating aspects of this cold is its stability. On land, temperatures swing daily and seasonally. We mark our lives by the cycles of warmth and chill, spring and summer, autumn and winter. In the Twilight Zone, seasons mean little. Sunlight never reaches here, so the water does not change with the calendar. It remains the same year after year, decade after decade, a near constant chill that makes this part of the ocean one of the most stable environments on Earth. For animals, that stability is both a blessing and a limitation. It means predictable conditions, but it also means no chance to escape. There is no warm refuge, no seasonal relief. Survival depends entirely on being built for cold. The lack of warmth also shapes the chemistry of the water itself. Cold water holds more oxygen than warm water, but paradoxically, some twilight depths contain layers where oxygen is scarce. These oxygen minimum zones form because sinking organic matter decomposes, consuming oxygen, while the lack of photosynthesis prevents it from being replaced. In these layers, life must adapt again, surviving not only cold but also thin oxygen. Some creatures slow their metabolism even further. Others carry special hemoglobins that cling tightly to every available molecule of oxygen. It is a delicate balance, one that makes these regions both challenging and full of specialized life. Humans sometimes imagine the deep ocean as empty, lifeless, frozen, but that is far from the truth. The cold here is not the cold of death. It is the cold of adaptation, of a world where life runs at a slower rhythm but continues nonetheless. Schools of lanternfish drift together, flashing their tiny lights. Squid hover with arms spread, waiting for prey. Shrimp and krill rise and fall with the daily cycle. All of them live in water that would freeze us solid in minutes. Yet to them, it is as normal as air is to us. The stability of this cold also makes the Twilight Zone a vital part of the planet's climate system. Cold water sinks, carrying with it carbon and nutrients from the surface. This process, known as the biological pump, helps regulate the balance of gases in Earth's atmosphere. The chill of the Twilight Zone is part of the engine that drives ocean circulation, linking the shallow seas with the abyss and shaping weather patterns across the globe. Without it, the climate we depend on would be very different. It is strange to think that while we shiver in winter storms or seek relief in summer heat, most of the planet's habitable volume never changes temperature at all. The Twilight Zone is a world where cold without end rules, silent and steady. Its residents have no need for seasons, no expectation of warmth. They live in a time outside our cycles, tuned instead to the eternal chill of the deep. Explorers who have descended into these waters often describe the cold not only as a physical fact but as a presence. Even inside heated submersibles, the awareness of being surrounded by such unrelenting chill is hard to ignore. It seeps into the mind, a reminder of how fragile human bodies are in the face of nature's vastness. Instruments fog, equipment stiffens, and the knowledge that only thin layers of metal stand between you and water, near freezing, sharpens the sense of isolation. The cold of the Twilight Zone is not simply environmental, it is psychological, a constant reminder of where you are and how little you belong. But for the creatures who do belong, this cold is not frightening. It is the fabric of their existence. They spawn, feed, migrate, and die in waters that never rise above a few degrees. Some never leave this environment at all, spending their entire lives in the slow rhythm of deep chill. Others commute daily to warmer layers above, but always return, drawn back into the steady cold like a home. For them, warmth would be disorienting, even dangerous. Their bodies are tuned for low temperatures, and sudden heat could disrupt their balance. What we crave, they avoid. What we fear, they embrace. It is a reminder that life is not universal in its needs. We think of heat as comfort, but comfort is a human idea. For the Twilight Zone, comfort is stability, and stability is cold. This is the world as it exists far beneath the waves, silent, pressurized, stripped of colour, and ruled by chill that never fades. As the cold settles deeper, the next thing that emerges is the strangeness of the residents themselves. Adaptations to pressure, darkness, and low temperature create forms of life that seem almost imaginary. Creatures of shadows drift through this endless dusk, bodies shaped in ways that challenge our sense of what animals should look like. From the tiniest drifting plankton to fish with enormous eyes and toothy jaws, the Twilight Zone is crowded with beings sculpted by conditions we can barely imagine. Life in the Twilight Zone often seems like it should be sparse, as if the fading light, the immense pressure, and the steady cold would make it impossible for animals to thrive. For a long time, scientists assumed that was true. They believed the deep mid-ocean was a barren desert, empty of life, nothing more than water stretching endlessly between the surface and the sea floor. But when nets began to return with strange, glittering bodies, and when lights from submersibles revealed flashes in the gloom, that belief crumbled. Far from being empty, the Twilight Zone is home to a vast community of creatures, many of them so unlike anything on the surface that they look like shadows made flesh. Most of these animals have evolved in ways that allow them to blend into their dim surroundings. They're not painted in bright colours like reef fish, or built for speed like tuna near the surface. Instead, they are creatures of compromise and adaptation, shaped by scarcity and secrecy. Their bodies are often slender, their muscles soft, their bones reduced. They are designed to waste as little energy as possible. Many drift more than they swim, letting the currents carry them while they wait for opportunities. When they do move, their actions are measured, deliberate, sometimes startling in their suddenness but never wasteful. The lanternfish is one of the most common residents here, and perhaps the most important. Though only a few centimetres long, they are believed to be among the most abundant vertebrates on Earth, with trillions living in the Twilight Zone. Their bodies shimmer with photophores that can glow in the dark, creating patterns of light used to confuse predators or signal to others of their kind. At night, they rise in enormous schools toward the surface, feeding on plankton before sinking back down by day to hide in the shadows. This daily commute, carried out by billions at once, is thought to be the largest movement of animals on the planet, dwarfing the great migrations of wildebeest or caribou on land. Other fish take on stranger shapes. Hatchet fish, with their thin, flattened bodies, look like slivers of metal drifting through the water. Their sides shine with silvery scales that reflect faint light, making them nearly invisible from a distance. Their large eyes tilt upward, designed to spot silhouettes above against the faint glow from the surface. With these adaptations, they hunt quietly, always alert, always ready to vanish back into the dimness. Then there are the bristlemouths, tiny fish with oversized mouths filled with needle-like teeth. Though small and unimpressive individually, their sheer numbers may rival those of lanternfish. They drift through the Twilight Zone in staggering quantities, feeding on plankton and small prey, forming the foundation of much of the food chain. To us they look almost comical, little more than mouths with fins, but they are among the most successful creatures on Earth, precisely because their design is so efficient for this environment. The Twilight Zone is also filled with squid, some small and delicate, others larger and more formidable. These cephalopods are masters of adaptation, able to shift colour and pattern even in near darkness. Some possess glowing organs that act like headlights or lures. Others produce sudden flashes of light to startle predators. Their arms and tentacles are lined with suckers, hooks, or even teeth, built to seize prey quickly in a place where opportunities are rare and meals cannot be wasted. Among the most haunting creatures of shadows are the dragonfish. Long, slender, and equipped with oversized jaws, they look like something imagined in a nightmare. Some species carry luminous lures that dangle in front of their mouths, tempting prey into range. Others can produce red bioluminescence, a rarity in the deep, allowing them to see prey without being seen themselves. Their bodies are fragile and soft, almost gelatinous, yet their teeth are sharp and their hunting tactics precise. They remind us that in the deep, appearances can be deceiving. Fragility and ferocity often coexist. Jellyfish are also common here, drifting with slow, graceful pulses. Their bells glow faintly, their tentacles trail behind them like threads of silk. Some are tiny, barely visible, while others stretch for meters. Comb jellies with rows of beating cilia scatter light into rainbow glimmers, like living prisms drifting in the dark. These creatures are almost entirely transparent, their bodies made mostly of water, yet they are predators all the same, catching plankton and small fish with sticky tentacles or engulfing them whole. Shrimp and krill form another major part of this world. They swarm in great numbers, feeding on marine snow and plankton, serving as prey for fish, squid, and whales. Many are transparent or tinted red, their colours hidden by the absence of red light. Some species can produce bursts of glowing fluid when threatened, creating clouds of light to distract predators as they escape. It is a reminder that in the Twilight Zone, light itself is as much a weapon as teeth or claws. Larger predators also visit these depths. Sperm whales, for example, dive deep into the twilight and even deeper into the midnight zone in search of squid. Their immense bodies withstand pressure that would destroy ours, and their echolocation clicks echo through the water as they hunt. These dives are temporary visits, but they tie the Twilight Zone to the surface in powerful ways, linking ecosystems across vast distances. When scientists first began studying twilight creatures, they were astonished not only by their variety but also by their abundance. The Twilight Zone may hold more fish by weight than all the world's fisheries combined. These animals form the backbone of ocean food webs, transferring energy from the surface to the depths, supporting predators as diverse as tuna, sharks, seals and whales. Without them, the balance of the seas would collapse. Yet for all their importance, most of these creatures remain mysterious. Nets capture only a fraction of what lives here, often damaging delicate bodies in the process. Submersibles see only narrow glimpses in the beam of their lights. Even today, scientists suspect that many species remain undiscovered, drifting in the darkness beyond our reach. Every new expedition brings reports of strange forms, fish with tubular eyes that rotate in their sockets, shrimp that look like glass, worms that glow with eerie patterns. It is a reminder that the Twilight Zone is still one of the least understood habitats on Earth, despite being so vast. These creatures of shadows also remind us of how much survival depends on context. On land, a transparent body or glowing organs would seem bizarre. In the Twilight Zone, they are normal, even necessary. Evolution has shaped life here not to dazzle us but to endure in conditions we would find unlivable. The results look alien because our expectations are built on sunlight, warmth, and air. Take those away, and life invents different solutions. Imagine drifting here yourself, surrounded by these forms. A lanternfish flickers below, its body shimmering with dots of light. A dragonfish glides past, jaws agape, its lure glowing faintly red. Above, a jellyfish pulses, its bell transparent, its tentacles trailing threads of light. Shrimp swarm nearby, invisible until they scatter with sudden flashes. You are in the middle of a crowd, but not a noisy one. It is silent, almost serene, each creature moving according to rhythms older than history. These are not monsters, but residents, at home in their endless dusk. What unites them is not size, shape, or behaviour, but their shared adaptation to shadows. They live in a place where light is scarce, where pressure is heavy, where cold never lifts. They are creatures of compromise, balancing fragility with resilience, hiding and hunting in ways that depend on invisibility. They remind us that life is not always about flourishing in abundance. Sometimes it is about enduring in scarcity, finding ways to survive where others cannot. And as you watch them drift, you begin to see that the Twilight Zone is not empty at all. It is full, crowded, alive, but in ways subtle and strange. It is a world where shadows rule, and where survival has been rewritten in forms we are only beginning to understand. As we keep sinking, the next lesson is in invisibility itself. These animals are not only creatures of shadows, but masters of disguise. In the deep, to be seen is often to be eaten, and so, life has invented remarkable tricks. Bodies that vanish, colours that cannot be seen, and skin that bends light itself. In a world where sunlight grows weaker with every metre, the line between life and death often comes down to whether an animal can be seen. In the Twilight Zone, visibility is both rare and dangerous. Unlike the sunlit waters near the surface where coral fish paint themselves in dazzling patterns to warn or attract, down here the goal is often the opposite. The safest strategy is not to be noticed at all. The result is a dazzling collection of camouflage techniques, honed by millions of years of evolution, each one designed to turn bodies into shadows or erase them entirely. The most common trick is transparency. Many twilight animals are almost completely see-through. Their muscles and tissues reduce to clear gels that allow light to pass straight through. Shrimp, jellyfish, small fish, even some squid. When they drift by, they are little more than faint outlines against the water. To predators scanning upward, these bodies vanish into the faint glow of the surface above. For prey looking downward, they blend seamlessly into the shadows. Transparency is one of the simplest and most effective solutions in a place where light is scarce but not gone. To our eyes in an aquarium, it makes them look fragile, ghostly, but in the wild it makes them nearly invisible. Other creatures turn to colour, though not the kind we're used to seeing. In the Twilight Zone, red is as close to invisibility as nature provides. Because red light is absorbed quickly by water and does not penetrate beyond a few dozen meters, anything coloured red at greater depths appears black. Many shrimp and fish are painted in deep crimson hues, which on land would make them obvious, but in the twilight makes them vanish into the dark. Scientists hauling nets from hundreds of meters below are often surprised to find vibrant scarlet animals, where they expected only drab grey. To our eyes under bright lights, they blaze with colour. To their neighbours in the twilight they disappear. Some fish go even further by wearing reflective skins. Silver-sided fish like hatchetfish are masters of this technique. Their scales are arranged to act like mirrors, bouncing back whatever faint light filters down. The result is a body that reflects the background perfectly, blending into its surroundings from every angle. Predators searching for a meal may swim past without noticing them at all. These mirror-like skins are so effective that they have inspired human technologies, from military camouflage to materials designed to reduce glare. The ocean was experimenting with these ideas long before we thought to imitate them. But camouflage in the Twilight Zone is not only about hiding from sight, it is also about controlling the way light is used. Many animals possess photophores, organs that emit their own glow. At first, this might seem like the opposite of camouflage, but bioluminescence can be used to erase shadows. Some fish use counter-illumination, glowing faintly on their undersides to match the dim light filtering down from above. To predators below, this cancels out the animal's silhouette, making it disappear into the background. It is like holding a flashlight under your chin, in perfect proportion to erase your outline. The precision is remarkable, with some species adjusting the brightness of their glow, depending on how much natural light is around them. This kind of camouflage is not limited to small fish. Squid too have mastered the art. Some can control thousands of tiny light-producing cells, adjusting their patterns to blend into the dimness or to confuse predators. Others release clouds of glowing fluid when attacked, much like ink in shallow water squid, but brighter, scattering light and providing cover as they escape. In the dark, light itself becomes a cloak, a diversion, or a shield. There are also adaptations that seem almost magical in their effect. Certain species of fish and crustaceans have bodies coated in microscopic structures that scatter light in unusual ways, making them appear nearly invisible even when illuminated by artificial lamps from submarines. These nanostructures bend and reflect a light in ways scientists are only beginning to understand, offering inspiration for materials science and optics. For the animals, it means survival against predators equipped with sharp eyes. For us, it is a reminder of how evolution has solved problems we're only starting to explore with our own technology. The masters of camouflage in the Twilight Zone are not limited to prey species. Predators too benefit from invisibility. Dragonfish use their slender black bodies to hide in plain sight while dangling glowing lures in front of their jaws. To unsuspecting prey, the lure looks like a harmless spark. By the time they notice the faint outline of the dragonfish, it is too late. Gulper eels use their dark skin and enormous mouths to lie in wait, striking suddenly when a victim drifts too close. In the Twilight Zone, the difference between hunter and hunted often comes down to who disappears better. Humans often think of camouflage as static, like the stripes of a tiger or the green of a soldier's uniform. But in the Twilight Zone, it is dynamic. Many animals can change their appearance in response to conditions. Squid and certain fish shift their glow, adjusting the intensity of their counter-illumination. Some creatures can expand or contract reflective cells in their skin, altering how much light they scatter. Others become more or less transparent depending on stress, food, or time of day. Camouflage here is not a fixed costume but a flexible tool, adapted moment by moment. It is humbling to realise how thoroughly life here is built around the idea of not being seen. On the surface, many animals thrive on visibility, using colour to attract mates, warn predators, or intimidate rivals. In the Twilight, the exact opposite is true. To be visible is to be vulnerable. Safety lies in silence and invisibility. The animals that master camouflage survive, those that fail become food. It is a constant game of adjustments, with evolution rewarding every trick that makes an animal blend just a little better into the endless dusk. Imagine drifting at 600 meters, the light barely strong enough to see. Around you, countless creatures are present, but you cannot tell. The water seems empty until suddenly a fish shifts, its reflective side catching your eye before it vanishes again. A jellyfish pulses slowly, invisible until a faint glow reveals its form. A shrimp swims past, red in truth, but black to your sight. For every one you glimpse, dozens more remain hidden. You realise the Twilight Zone is not barren at all. It is crowded but camouflaged so perfectly that most of its residents escape notice. The ingenuity of these camouflage strategies has not gone unnoticed by science. Researchers study the reflective skins of hatchetfish to design better materials for stealth technology. They analyse the light organs of squid to create efficient glowing devices. They investigate the nanostructures on transparent animals to improve optical coatings. The ocean's solutions to invisibility are slowly becoming human tools. What for the creatures is survival becomes for us a source of innovation. Yet even with these insights, the Twilight Zone remains a mystery. Many camouflage strategies are still poorly understood. Some fish appear invisible even under bright submarine lights, suggesting mechanisms we have not yet identified. Others may rely on chemical signals, blending not only visually but in scent and taste. Our senses are too limited to grasp the full range of tricks at play. To truly understand them, we would need to inhabit their world completely, to see as they see and feel as they feel. Camouflage in the Twilight Zone is not just a set of clever adaptations, it is the essence of life here. In a place where survival is uncertain, where food is scarce, and where predators lurk in every shadow, invisibility is the most powerful defense. Whether by transparency, color, reflection, or light, animals here become shadows themselves. They are present but unseen, living ghosts drifting in the blue-black water, and as you follow them deeper, you begin to notice something else. Camouflage is not always about vanishing. Sometimes it is about reappearing in unexpected ways. Light does not only hide but also communicates. The same organs that erase shadows can flash signals. The same glow that blends with background can blaze in sudden patterns. Ahead lies not just invisibility but illumination, the strange and mesmerizing art of making light in a world where the sun has vanished. When the last traces of sunlight dissolve into the deep, it might seem like nothing but blackness should remain. Yet the Twilight Zone is anything but dark. Here, in the absence of the sun, life itself has become the source of light. Across this vast band of ocean, countless creatures carry lanterns inside their bodies, tiny organs called photophores that glow in patterns, pulses, or steady beams. The result is a drifting galaxy beneath the waves, a sky inverted, with stars moving not above us but around us, alive and breathing. Bioluminescence is the language of this hidden world. It is not just decoration, it is survival. The light comes from chemical reactions, most often involving a molecule called luciferin and an enzyme called luciferase. When the enzyme acts on the molecule, energy is released as visible light. Some species produce their own luciferin, while others rely on symbiotic bacteria that glow inside specialized organs. To the human eye, the light is usually blue or green, the colors that travel farthest through water. It is no coincidence. In a place where other wavelengths vanish, blue and green become the universal script. For many animals, bioluminescence is camouflage in reverse. Counter-illumination, where fish glow on their undersides to erase their shadows, is one of the most common uses. The brightness of the glow can be adjusted to match the faint light filtering from the surface. A predator looking up sees only a blank patch of water, unaware that a fish is swimming above. Some species carry this precision to astonishing levels, their light organs capable of fine-tuning intensity as the sun sets, clouds shift, or the moon changes phase. It is camouflage not by hiding, but by glowing just enough to disappear. Other animals use their lights as lures. The classic example is the anglerfish, though many species of dragonfish and squid use similar tactics. A dangling filament glows softly, mimicking the movements of small prey. Curious fish approach, drawn by the spark in the darkness, and find themselves suddenly engulfed by jaws waiting in the gloom. These lights are not only bait but weapons, turning the absence of sunlight into an advantage for hunters. Some bioluminescence serves as defense. Shrimp, when threatened, can eject clouds of glowing fluid, confusing predators and giving themselves time to escape. Squid release bursts of light that act like underwater flashbangs, stunning and startling their pursuers. Jellyfish ripple with sudden flashes, perhaps to warn predators that they are not worth eating, or perhaps to attract larger predators that might attack the attacker. In this way, light becomes a shield, a diversion, a desperate cry in the dark. Communication is another vital role. Lanternfish use bioluminescent spots along their bodies to recognize each other, signaling with patterns unique to their species. Some flash in sequences, while others maintain steady glows. In a place where vision is limited and colors have vanished, these signals are crucial for finding mates, identifying allies, or coordinating group movements. What to us looks like random twinkling is, to them, a structured conversation. The beauty of these lights is difficult to convey. Submersible crews describe drifting through the Twilight Zone as entering a silent fireworks show. Tiny sparks flare and fade, waves of glow ripple through schools, and sudden flashes break the monotony of dimness. At times, the movement of the submersible itself triggers displays, as startled creatures unleash their lights in defense. The result is like watching constellations burst into life around you. But unlike the fixed stars of the sky, these are alive, responding, adapting in real time. For humans, witnessing bioluminescence firsthand can feel transformative. Divers in shallow seas sometimes encounter glowing plankton, tiny organisms that emit brief sparks when disturbed. Swimming through them at night creates trails of light, as though one's hands and fins have become brushes painting across the sea. These shallow displays are only hints of what happens below. In the Twilight Zone, bioluminescence is not rare. It is nearly universal. Some scientists estimate that more than 3/4 of the creatures living here can produce light in some form. That makes this the most bioluminescent habitat on Earth, a place where darkness has been turned into a stage for endless performances of survival. The efficiency of this adaptation is remarkable. Bioluminescent reactions produce very little heat. Almost all the energy is converted directly into light, a perfect solution in a place where conserving energy is vital. The light can be switched on and off quickly, adjusted in intensity, and directed through lenses or reflectors built into the body. Some species even have shutters that allow them to block or reveal their glow, as if flipping a switch. It is not crude or accidental. It is precise, controlled, purposeful. The diversity of bioluminescent strategies is staggering. Some fish glow only in the head or along the belly. Others carry lights on fins, tails, or even eyelids. Squid may flash in waves across their bodies, while shrimp ignite sudden bursts. Certain jellyfish emit continuous glows, while others pulse rhythmically. Dragonfish produce light from long chin barbs, creating eerie dangling lanterns. Each design serves a purpose, refined by generations of survival in the deep. The role of red light deserves special mention. While blue and green dominate, a few species can produce red bioluminescence, an ability almost unheard of in the ocean. Dragonfish use this trick to illuminate prey without being seen themselves. Because most animals in the Twilight Zone cannot detect red, it is effectively invisible. The dragonfish, however, has evolved eyes sensitive to it, giving them a private spotlight. To their prey, the darkness is total. To the dragonfish, the scene is lit. It is an extraordinary example of evolutionary innovation, turning the disappearance of colours into an advantage. Humans have long been fascinated by glowing life. Ancient sailors told stories of seas that shimmered at night, believing them to be signs of spirits or omens. Today we know these lights are biological, yet the wonder remains. Bioluminescence has inspired art, literature and science. Researchers study it to develop medical imaging tools, molecular markers, and new lighting technologies. Fireflies on land and lanternfish in the sea share the same basic chemistry, proof of how widespread and successful this adaptation is. But here in the Twilight Zone, bioluminescence is not a curiosity. It is the rule. It is the thread that connects predator and prey, the common language of communication, the method of hiding and hunting alike. To imagine this place without glowing life is to imagine it empty. The animals are not just shadows, they are lanterns carrying their own stars into the depths. If you picture yourself sinking among them, it is like entering a reversed night sky. Instead of standing on land and gazing upward at constellations, you float downward, and the constellations swim beside you. Each spark is alive, each flicker purposeful, each glow a message or a trick. It is not random beauty. It is life written in light, survival written in sparks. And as you drift further into this galaxy of living lanterns, you begin to realize that not all light here is gentle. Some belongs to hunters, waiting patiently for victims to approach. Some belongs to prey, flashing desperately in defense. The next step in our descent is to meet the predators of this realm, the silent hunters shaped by a world where glowing signals can mean salvation or doom. Predators in the Twilight Zone do not stalk their prey with speed or strength, in the way we picture sharks slicing through the surface waters or lions sprinting across the plains. Here, hunting is a slower, quieter affair. In a realm where energy is scarce, every movement must be calculated. A wasted chase could mean starvation. Success depends less on brute force and more on patience, trickery, and silence. One of the most iconic hunters here is the dragonfish. With its elongated body and enormous jaws, it looks like something from a nightmare. Its teeth are long, thin, and curved backward, designed to trap prey that wanders too close. Some species have light organs dangling from their chins, glowing faintly like fishing lures. In the deep gloom, these sparks are irresistible to smaller fish. They drift near, curious, unaware that the light is attached to a mouth waiting to snap shut. The dragonfish's body is soft and fragile, but its jaws are a weapon of precision. It does not need to swim fast or strong. It simply waits, hidden in darkness, and lets curiosity do the work. Another hunter of note is the viperfish. Its head is massive compared to its body, and its jaws are lined with teeth so long they cannot fit inside its mouth, curving upward like needles. The viperfish relies on ambush, hanging motionless in the water until prey swims within reach. Then, with a sudden strike, it lunges forward, impaling its victim before it can react. It too carries bioluminescent organs, sometimes along its sides, sometimes as a lure. The combination of invisibility and sudden ferocity makes it one of the most feared predators in the Twilight Zone, even though it is only a few dozen centimeters long. Squid also play the role of silent hunters. Many species in the Twilight Zone are small, but some grow large, using long tentacles equipped with suckers or hooks to seize prey. They can hover in place, blending into the dimness, then dart forward in an instant, propelled by jets of water. Some release sudden flashes of light to confuse their targets, while others use stealth, approaching from below where their silhouette is least visible. Their hunting is opportunistic, guided by senses far sharper than ours, able to detect vibrations or faint glows invisible to human eyes. The gulper eel is another strange predator, its mouth capable of opening so wide it can engulf prey almost as large as itself. Its body is long and slender with a small head until the jaws extend, transforming it into something monstrous. Unlike the swift attacks of surface hunters, the gulper eel's method is more like a trapdoor. It drifts, mouth agape, waiting for something edible to blunder in. In a place where meals are uncertain, swallowing large prey whole is an advantage, even if it means long periods between feedings. Not all silent hunters rely on jaws and teeth. Some use light itself as a weapon. Certain species of squid and shrimp can release glowing clouds to startle prey as well as predators. Others use sudden bursts of light to disorient their targets, seizing them in the confusion. The dragonfish's red bioluminescence gives it an invisible spotlight, allowing it to hunt prey that never realizes it is being illuminated. These strategies turn the absence of sunlight into a battleground, where the very act of seeing is uneven. Some can see what others cannot, and in that imbalance lies the advantage of the hunter. What unites these predators is restraint. Unlike surface hunters, which may chase their prey with abandon, Twilight hunters conserve energy. They move only when they must. Their bodies are often soft, their muscles reduced, because speed is not the goal. Success depends on invisibility, patience, and timing. To watch them is to see predators that do not look imposing at first glance, but that are perfectly suited to their world. They are not chasing machines. They are ambush artists, liars in wait. Sperm whales are temporary visitors to these depths, but when they arrive, they embody another kind of silent hunting. Using echolocation clicks, they search for squid in the twilight and deeper. Their dives can last more than an hour, their bodies descending silently through the water until they find their quarry. The whale's method is not flashy, it is careful, deliberate, honed by millennia of practice. These encounters remind us that the Twilight Zone is not cut off from the rest of life, but connected, feeding creatures that roam the surface and beyond. The silence of these hunters is not only physical, but also sensory. The Twilight Zone is a place where sound carries far. Many creatures rely on vibrations or clicks, but predators often remain quiet. They do not announce their presence with noise. They let the darkness and the pressure conceal them. Prey often has little warning until it is too late. That is why so many twilight animals invest in camouflage, bioluminescence, or transparency. To survive here, one must assume that danger is always nearby, even if unseen. For humans imagining these predators, it can be tempting to think of them as terrifying monsters. Their teeth are long, their eyes are huge, their bodies are strange, but their forms are simply the result of necessity. In the Twilight Zone, success requires different solutions than in the shallows. Teeth grow oversized because food is rare and must not be lost once caught. Eyes are huge because light is scarce and every photon counts. Bodies are soft because strength is unnecessary when patience and stealth bring better results. They look monstrous to us only because our reference is the surface world. Down here, they are exactly as they should be. Picture yourself drifting among them. At first the water seems empty, only dim blue shadows surrounding you. Then suddenly a spark glows faintly in the distance. It drifts closer, swaying gently. You realize it's a lure, and as your eyes adjust you see the outline of a dragonfish, its jaws barely moving, its body hovering silently. You look away, and another shape emerges, a hatchet fish reflecting faint light, then vanishing. A viperfish hangs motionless, its teeth glinting briefly as it waits. All around you, the predators are there, but they do not rush, they do not roar. They wait, patient and quiet, until the right moment comes. This kind of hunting requires not only adaptation but also balance. If every predator hunted constantly, the prey would vanish quickly. Instead, life here operates on rhythms, cycles of feeding, migration, and waiting. The largest daily migration in the world, the upward movement of fish, squid, and plankton at night, provides hunters with their opportunities. They feed when prey rises near the surface, then retreat by day to conserve energy. The rhythm of twilight life is dictated not only by the fading sun, but also by the silent strategies of hunters and the evasions of prey. The more we study these predators, the more we see the elegance in their silence. They embody efficiency, using as little as possible to gain as much as they need. Their patience is not laziness, but wisdom built into biology. In the twilight zone, soundless, patient predators are the only kind that can endure. As we drift onward into this realm, we move from the hunters themselves to the stage they inhabit. The twilight zone is not only filled with creatures, but also with particles drifting down from above, a constant snowfall of organic matter that sustains the hunters and the hunted alike. It is the quiet rain of life that makes this strange theatre possible, and to understand the twilight, we must look closely at the snow that never melts. Every evening, just as the sun slips below the horizon, the ocean begins to move in ways invisible to anyone standing on the shore. It happens not with crashing waves or violent storms, but with the rising of countless bodies from the depths. Tiny plankton, small fish, shrimp, squid, and a host of other creatures begin to swim upward, leaving the cold dimness of the twilight zone for the shallows above. It is not a trickle. It is not scattered individuals drifting here and there. It is a migration on a scale greater than anything that happens on land, greater than the herds of wildebeest on the African plains, greater than the flights of birds across continents. It is the largest movement of life on the planet, and it happens every single day. Scientists call this deal vertical migration, the daily journey up and down through the water column. By day, animals hide in the twilight zone, using its dimness as protection against predators. By night, they rise closer to the surface where food is plentiful. Phytoplankton, tiny plants that float near the surface, bloom in sunlight, and at night they become vulnerable to grazers. The commuters arrive to feed, seizing the opportunity under the cover of darkness. By dawn, before sunlight can reveal them, they retreat downward again, disappearing back into the shadows. It is like the heartbeat of the ocean. Rise, feed, descend, hide, repeat. The scale of this journey is staggering. Imagine trillions of animals, from microscopic plankton to fish the length of your arm, all moving together in great waves, rising hundreds of meters through the water column. The movement is so massive that it changes the way sonar reflects off the sea, creating what early naval operators once thought was the seafloor itself shifting upward at night. They called it the deep scattering layer, a mysterious phantom seabed that rose and fell with the sun. Only later did scientists realize that it was not the bottom of the ocean moving, but an immense mass of life, rising and sinking in synchrony. The commuters are diverse, but their reasons are the same. For small fish and shrimp, the surface offers abundant food, but also great danger. In daylight, predators would see them easily, so they hide in the dim safety of the twilight. At night, with darkness to shield them, they ascend to eat. For the predators themselves, larger fish, squid, and even whales, the commuters are a moving banquet. They follow the migration, timing their own movements with precision, feeding during the upward rush and retreating with it at dawn. Every participant in this daily cycle is both traveller and target. The distances covered are impressive. For a human, swimming a few hundred meters vertically would be exhausting, even life-threatening without equipment. For twilight creatures, it is routine. Lanternfish rise hundreds of meters every night, guided by instincts written into their biology. Shrimp, krill and squid do the same. Even though the pressure shifts dramatically, these animals are adapted to handle it. Their bodies lack fragile air pockets, and their tissues are flexible, allowing them to rise and sink without harm. What would rupture and crush surface fish is just another part of daily life for the commuters. This migration has consequences far beyond the lives of the creatures themselves. It is one of the major engines of the planet's carbon cycle. As animals feed near the surface and then retreat to depth, they carry carbon with them, releasing waste and eventually dying in the twilight zone. This transfers carbon from the upper ocean into deeper waters where it can remain locked away for centuries. In a world where we worry about the buildup of carbon dioxide in the atmosphere, this daily commuting of billions of animals plays a quiet but crucial role in regulating Earth's climate. The commuters also transport nutrients. By feeding near the surface and excreting waste at depth, they help redistribute energy throughout the ocean. Nutrients that might otherwise remain trapped near the top are moved downward, supporting ecosystems far below. The Twilight Zone depends on this transfer. Without it, life here would be far thinner. In turn, predators at higher levels depend on the commuters themselves, creating a chain of interdependence that stretches from plankton to whales. For scientists, studying this migration is difficult. The movements happen at night, often in remote regions of the sea. Nets can capture some of the travellers, but they break apart easily, their bodies too delicate for rough handling. Submersibles and remote vehicles reveal glimpses, beams of light catching shimmering schools of lanternfish or drifting swarms of krill. But the full scope is still hard to measure. Satellites can detect changes in surface plankton, but they cannot see the migrants themselves. Even sonar, powerful as it is, offers only broad outlines. What we do know suggests that the biomass moving each night is immense, far greater than the total weight of all land animals combined. Imagine standing on the deck of a ship in the open ocean. The sea looks quiet under the stars, perhaps stirred only by gentle swells. But beneath the surface an invisible tide of life is surging upward. Shrimp pulse their bodies, fish flick their fins, squid jet through the water, all moving toward food. They rise not in silence exactly, but in a way that our ears cannot detect. The ocean hums with motion too subtle for us to sense. By dawn, it will all retreat again, as if nothing happened. But it happens every day, endlessly repeating, shaping the balance of the seas. This migration has been going on for millions of years, long before humans thought to measure it. It is one of the most ancient rhythms of life on Earth, more consistent than the migrations of birds or mammals, more reliable than the blooming of forests or the turning of leaves. It is as steady as the rising and setting of the sun, because it is driven by that very cycle. Light and dark dictate the timing, and life has built itself around it. For the commuters themselves, the journey is risky. Each night they expose themselves to predators waiting near the surface. Each morning they must hurry back before daylight reveals them. Yet the rewards outweigh the risks. The surface holds food too abundant to ignore. The twilight alone cannot sustain them. This constant gamble, safety in the shadows or food in the open, is the core of their existence. And because so many species make the same choice, the migration becomes a vast, synchronized movement, a pulse that unites life across the ocean. Humans rarely witness it directly, but its effects ripple outward. Fisheries that depend on surface predators like tuna and swordfish are indirectly sustained by the commuters. Whales time their movements with the rising of krill swarms. Even seabirds benefit, diving at night to snatch fish drawn upward. The commuters are hidden most of the time, but they support chains of life that reach far above them. If you imagine yourself sinking into the twilight zone at dusk, you would see the migration begin. At first the water is quiet, only a few drifting forms around you. Then, gradually, shadows appear from below. First a few lanternfish, then more until hundreds surround you. Shrimp flicker past, their bodies faintly glowing. Squid rise, arms spread. Within minutes the water is filled with motion, a living river flowing upward. You would feel as though you were caught in a crowd, a swarm so vast it seems endless. And then, hours later, as the horizon begins to glow again, the tide would reverse. The commuters would vanish downward, melting back into the gloom until the cycle repeats at nightfall. This daily journey is easy to overlook, invisible from land, hidden in the dark. But it is one of the foundations of the ocean's balance, a quiet choreography of rise and fall, ascent and retreat. It is the reason the Twilight Zone is not barren but alive, constantly refreshed by the movement of energy and bodies. Without these commuters, the seas would look very different, and so would life on Earth. As we follow them downward again, leaving the surface behind, we return fully to the realm of Twilight. Here, life not only commutes but also waits. Particles drift constantly from above, a snow that never melts, feeding those who choose not to rise. To understand the Twilight Zone fully, we must watch this slow, steady fall of nourishment, the endless rain of life that sustains everything below. Life in the Twilight Zone is tied together by threads that are fragile yet unbreakable, woven into networks of eating and being eaten that are as complex as any forest or savanna above the surface. When people imagine food chains, they often think in straight lines. Plankton eaten by small fish, which are eaten by bigger fish, which are eaten by sharks. But the Twilight Zone is not a place of neat hierarchies. It is a place of shifting roles, of hunters that become prey, of food arriving from above as much as from below, and of countless species sharing the same pathways of survival. At the very base of these food chains lies marine snow. It is a gentle rain of organic particles, drifting slowly from the surface, the remains of plankton, bits of algae, waste from fish, fragments of tiny shells, and the bodies of creatures that have died above. To us, it might look like dust, but for the Twilight Zone, it is a banquet. Each flake of marine snow carries energy from sunlight captured at the surface, and as it falls, animals intercept it, eating it directly or consuming the microbes that colonize it. Without this steady rain, the Twilight Zone would be a desert. With it, it becomes one of the largest habitats on Earth. Tiny zooplankton are among the first to feed on marine snow. Copepods, krill, and small jelly-like creatures graze on these drifting particles, filtering them from the water. These plankton are themselves food for larger creatures: lanternfish, bristlemouths, hatchetfish, and countless others. The Twilight Zone is filled with these small to medium fish, often no longer than a finger, but present in staggering numbers. They form dense schools that shimmer faintly in the dim light, pulsing with bioluminescence as they move. They are the main link between the drifting particles of marine snow and the higher levels of the food web. Predators, both permanent residents and visiting hunters, depend on these schools. Dragonfish hover, waiting for a lanternfish to stray. Viperfish snap at bristlemouths that drift too close. Squid dart among the swarms, seizing shrimp and small fish with their tentacles. Even whales, enormous compared to their prey, dive deep to feed on krill or lanternfish in immense gulps. The Twilight Zone may seem forbidding to us, but it is full of mouths, each adapted to catch something just a little smaller than itself. But food chains here are not fixed. A lanternfish may feed on plankton one moment, then be swallowed by a dragonfish the next, which in turn may become prey to a larger squid or a diving whale. Shrimp that graze on marine snow are hunted by fish, but those fish might also eat smaller shrimp themselves. The roles shift constantly, forming webs rather than straight chains. Every creature is both consumer and consumed, part of a cycle that has no true beginning or end. One fascinating aspect of Twilight food chains is the importance of size. On land, a mouse can survive by hiding from predators. In the ocean, size often determines fate more directly. Small creatures can only hope to stay hidden, while larger ones must become predators to sustain themselves. But even the large are not safe. A squid may devour dozens of fish in a night, only to be swallowed whole by a sperm whale. The food chain here is not a ladder with rungs leading upward, but more like a wheel, turning endlessly, with each creature playing many roles. Bioluminescence adds another layer of complexity. Lights are used not only to attract mates or lure prey, but also to influence feeding. Some fish flash patterns that startle smaller animals, making them easier to catch. Others glow to communicate with their own kind, coordinating movements that herd prey into dense schools. For predators, following these lights can mean dinner. For prey, misreading them can mean death. The Twilight Zone's food web is not only a matter of who eats whom, but also of who can decode the language of light and who cannot. Migration deepens these connections further. At night, when commuters rise toward the surface, they carry the twilight food chains upward with them. They feed on surface plankton, then carry that energy back into the depths when they return at dawn. Predators follow, feeding along the way. This vertical link ties surface ecosystems to the deep. Without it, the Twilight Zone would depend only on the slow trickle of marine snow. With it, there is a constant flow of energy, refreshed daily, binding together the surface world and the Twilight realm. Humans are only beginning to understand how vast these chains are. Estimates suggest that lanternfish alone may make up hundreds of millions of tons of biomass. If these fish vanished, predators like tuna, swordfish, squid, seals, and whales would all suffer. The Twilight Zone quietly supports fisheries that feed billions of people, though most of us never think about it. The chain is invisible to us, but we depend on it. One way to grasp this is to imagine the Twilight Zone as an enormous, hidden pasture. The marine snow is the grass, the plankton are the grazers, the fish are the herds, and the predators are the hunters circling around them. But unlike a pasture on land, this one stretches across the entire planet, vast beyond imagining, and the animals graze in 3 dimensions, moving up and down as much as they move side to side. It is a pasture without boundaries, yet carefully balanced by the flow of energy from the sunlit surface down into the shadows. This balance is delicate. If the supply of marine snow were disrupted, the entire system would falter. If predators were removed, prey populations could explode and then crash. If the commuters stopped rising, surface ecosystems would lose their connection to the deep. Every part depends on every other. That is why scientists worry about overfishing in the Twilight Zone. Removing too many lanternfish or krill could unravel chains that sustain not just twilight life, but surface predators and human economies as well. The food chains here are also astonishing in their efficiency. Very little goes to waste. A fish that dies becomes marine snow. Waste from predators feeds plankton. Even tiny fragments of organic matter are consumed by microbes, which in turn are eaten by plankton again. The cycle is nearly closed, with energy recycled at every level. It is one of the reasons life can persist in such vast numbers despite the scarcity of sunlight. Imagine watching these chains unfold. A flake of marine snow drifts past, caught by a copepod's grasping legs. The copepod is seized by a bristlemouth swallowed in a single gulp. The bristlemouth flashes its light briefly, then vanishes into the jaws of a dragonfish. The dragonfish hovers, only to be snatched by a squid rushing from below. The squid, strong but not invincible, is engulfed in turn by a diving whale. All of this from one particle of drifting matter, one thread in an endless network. Each link is temporary, each role reversible, but the chain itself continues without pause. What makes the Twilight Zone's food chain so remarkable is not just their size or their complexity, but their invisibility. They are happening constantly beneath the waves, unseen by us, shaping the ocean's balance and sustaining life on Earth. We do not watch them the way we watch lions hunt zebras or eagles catch fish, yet they are just as dramatic, just as vital, The difference is that the stage here is hidden, and the actors glow faintly in the dark rather than in sunlight. And as we follow these threads further downward, we begin to realise that the Twilight Zone is not only about what lives there now, but also about what falls from above. The rain of life, the slow drift of marine snow, is more than a food source. It is a record of the surface, carrying with it carbon, nutrients, and the story of life above. To understand the Twilight Zone's food chains fully, we must look at that steady fall, at how the surface world leaves its trace in the deep. If you sink into the Twilight Zone and look closely enough, you will notice that the water is never truly empty. Even when no fish swim past and no glowing sparks flicker nearby, something is always drifting downward. Tiny specks, flakes, and threads move slowly through the water like dust motes in a beam of light. They fall endlessly, silent and steady, from the surface above. This is marine snow, the falling snow of the sea, and it is one of the most important processes on Earth. At first glance, marine snow does not look like much. A faint sprinkle of particles too small to notice unless you shine a light on them. But each particle is a fragment of life. It may be a dead plankton cell, a bit of mucus, a pellet of waste, or the body of a small creature that did not survive the surface. Together these countless fragments make a gentle rain that sustains the Twilight Zone. Without it, there would be almost nothing to eat in these depths. With it, an entire hidden ecosystem thrives. The journey of marine snow begins at the surface. Sunlight feeds phytoplankton, the microscopic plants of the ocean. These plankton are grazed by zooplankton, which in turn are eaten by small fish, and so on up the chain. But not every bit of energy stays in the surface world. Some of it drifts downward, broken off as waste or as the remains of creatures that sink after death. Every storm of plankton blooms, every season of feeding, eventually leaves a trace in the snow that falls below. The snow drifts slowly, often taking weeks to travel from the surface to the deeper zones. Along the way, it is intercepted again and again. Small animals graze on it, breaking it into smaller pieces. Microbes colonize it, feeding on its organic matter and releasing nutrients. Larger particles clump together, falling faster, while smaller ones drift like powder. By the time the snow reaches the lower twilight or the midnight zone, much of it has already been consumed, but enough remains to support life even in the dark. For the creatures of the Twilight Zone, this snow is a constant source of food. Many species simply wait in the water column, filtering particles as they fall. Others actively search for denser clumps, gobbling them before they sink too deep. Some, like small crustaceans, gather snow into mucus webs, concentrating it into edible masses. It is not glamorous, but it is reliable, and in the deep sea, reliability is everything. The snow also shapes behaviour on larger scales. Many twilight creatures migrate upward at night to feed directly on plankton at the surface, but they still rely on the snow when they return. Marine snow connects the two worlds, the sunlit shallows and the dim depths, into a single system. Energy captured by sunlight does not stay at the top. It trickles downward, particle by particle, sustaining life far below. To humans, snow on land is a sign of seasons, a temporary transformation that melts with the sun. But in the ocean, the snow never stops. It falls every day in every season, across every sea. It is as constant as gravity itself, a steady reminder that what happens above affects what lies below. If a plankton bloom thrives, the snow thickens, feeding creatures deeper down. If surface life suffers, the snow thins, and twilight animals feel the hunger. It is an invisible link tying the fate of distant ecosystems together. The importance of this snow extends beyond food. It is also one of Earth's greatest tools for regulating climate. As carbon dioxide in the atmosphere feeds surface plankton, that carbon is absorbed into their bodies. When they die or when waste drifts downward, the carbon sinks with it. Some of it is consumed in the Twilight Zone. recycled into new life, but some continues to fall into the midnight zone and beyond, where it can remain trapped for centuries. This process, known as the biological pump, is one of the reasons Earth's climate is as stable as it is. The Twilight Zone is not only a home for strange creatures, it is a vital part of the planet's balance. Explorers who have descended into the depths often describe marine snow as both eerie and beautiful. In the beam of a submersible's light, the particles glow faintly, swirling like ash in still air. They drift slowly, hypnotically, a blizzard that never reaches the ground. For the humans watching, it feels almost magical, a reminder that the ocean is not empty space but a living medium filled with constant motion. For the creatures within it, it is simply dinner falling from the sky. The variety of material in marine snow is astonishing. One particle may be the skeleton of a diatom, a type of plankton with a glassy shell. Another may be a pellet of waste from a fish that fed hours earlier. Another may be a mucus blob carrying dozens of tiny microbes. Each particle tells a story of the surface world, of sunlight captured, of energy passed along, of death and renewal. Together, they are the autobiography of the ocean, written not in words but in falling fragments. The snow also affects how creatures evolve. Animals in the Twilight Zone do not waste energy chasing prey unnecessarily. Many are adapted to wait and filter, to conserve energy until food drifts into reach. Some, like gelatinous salps, form chains of bodies that filter enormous volumes of water, gathering snow as it falls. Others rely on sticky appendages or nets to trap particles. Evolution here rewards patience and efficiency more than speed or strength. The snow falls steadily, and those who can wait for it will eat. But marine snow is not always gentle. Sometimes it arrives in sudden storms. When surface blooms of plankton collapse, when large schools of fish die off, or when seasonal events release massive amounts of organic matter, the snow thickens into blizzards. During these times, the Twilight Zone becomes a feast. Animals gorge themselves, growing quickly, reproducing, storing energy for leaner times. These storms of snow can transform the balance of the deep, just as droughts or rains transform the land. For humans, the concept of eating waste and drifting debris may seem unpleasant. But in the Twilight Zone, nothing goes to waste. Every particle is used, recycled, consumed. Even after animals eat the snow, their own waste becomes part of it again, falling to feed others. This cycle ensures that energy captured at the surface is stretched as far as possible. In a place with so little light and so few resources, the efficiency is astonishing. Imagine yourself floating in the twilight, surrounded by falling snow. Each flake drifts past slowly, delicate and silent. Tiny shrimp dart to intercept them, snapping them up before they sink too far. Jelly-like creatures filter them in long strands, reeling in food from the water itself. Fish rise lazily, mouths open, swallowing clusters of particles. Around you, life thrives not by chasing but by waiting. You realize that this snow is not decoration. It is the foundation of everything here. And as you watch it fall, you begin to see how connected the ocean is. What begins in sunlight ends here as nourishment. The Twilight Zone is not separate from the surface, but part of a single system. The falling snow of the sea is the link between worlds, carrying energy downward, sustaining shadows with the memory of light. The further you descend, the thinner the snow becomes, until only the hardiest fragments survive. Yet even then, life finds a way. Microbes colonize the smallest bits. Bacteria break down what others cannot, and strange creatures of the Midnight Zone wait for what remains. The snow never stops, and as long as it falls, life in the deep continues. Life as we know it is built on sunlight. On land, it feeds plants, which feed herbivores, which in turn feed carnivores. In shallow seas, it drives the blooms of plankton that anchor the entire ocean's food web. Even the marine snow that sustains the Twilight Zone begins with photosynthesis in the sunlit surface. Yet the twilight zone itself exists outside direct sunlight. No plants grow here, no algae thrive, no photosynthesis is possible. This is a world that survives without the sun, and it does so in ways that feel almost alien compared to the surface. The most obvious adaptation is reliance on the rain of organic matter falling from above. Every flake of marine snow is a fragment of sunlight transformed into food. Twilight creatures have learned to stretch these fragments as far as possible, feeding slowly, conserving energy, and evolving strategies to capture even the smallest traces. Unlike surface animals that often grow quickly and move constantly, many twilight residents have metabolisms tuned for scarcity. They burn energy slowly, move deliberately, and accept long waits between meals. It is not about thriving in abundance, but about surviving in the absence of it. But the twilight zone is not only about passively waiting for food to fall. Some animals commute upward, rising into surface waters at night to feed where the plankton bloom. They risk predators in exchange for direct access to food. Their bodies are adapted to handle pressure changes as they move up and down hundreds of meters each day. They are like commuters travelling into a city for work, returning home by morning. This daily migration is one of the cleverest ways to bridge the gap between sunlight and shadow. Others use bioluminescence not just as camouflage but as tools for survival. Some lure prey with lights, turning their bodies into substitutes for the missing sun. A dangling spark draws a curious fish close, and jaws close around it. Others use flashes of light to startle attackers, giving themselves precious seconds to escape. Some even mimic the patterns of other species, tricking their prey into mistaking them for harmless company. Light becomes currency, used to feed, defend, and confuse, a replacement for sunlight created within the body itself. Predators in the twilight zone rely on patience more than pursuit. Speed is costly in a place without abundant energy, so ambush becomes the strategy of choice. Dragonfish hang motionless, waiting for something edible to drift close. Viperfish strike suddenly from stillness. Gulper eels open enormous jaws to swallow prey whole, storing energy from rare large meals. Survival here means minimizing waste, finding ways to turn brief opportunities into lasting sustenance. Some species show adaptation so strange they seem almost like science fiction. The barrelly fish, for example, has a transparent head filled with fluid, inside which its eyes rotate like turrets. These eyes can look upward through the dome of its skull to spot faint silhouettes against the weak light above, or forward when it needs to focus on prey. This bizarre design maximizes the tiny traces of light available, turning survival into an optical trick. To us it looks alien, but in the twilight zone it is simply practical. Another adaptation is gigantism among certain invertebrates. Creatures like amphipods, small crustaceans that in shallow waters are only millimeters long, grow to several centimeters in the twilight zone. Their larger size allows them to store more energy, endure longer between meals, and avoid being eaten as easily. This pattern repeats in other groups as well. Squids, worms, and jellyfish often grow far larger than their surface relatives. The scarcity of sunlight has not made them smaller, but paradoxically has encouraged some to grow to unusual sizes. The lack of sunlight also means that some creatures rely on chemical energy instead of photosynthesis. While the twilight zone does not host the extreme chemosynthetic communities found near hydrothermal vents in the abyss, microbes here can still feed on chemical reactions involving sinking organic matter or dissolved compounds. These microbes in turn become food for larger organisms, adding another link to the chain of survival without sun. It is a reminder that sunlight is not the only possible source of energy for life, even if it is the dominant one. Reproduction in the twilight zone also reflects the absence of sunlight. On the surface, many animals time their breeding with seasons, using changes in daylight as cues. In the deep, those cues vanish. Instead, twilight creatures often rely on internal rhythms or the timing of food availability. When marine snow thickens after a plankton bloom above, it signals a good time to reproduce. Some species release eggs and sperm into the water, letting currents carry them. Others brood young internally, giving them a better chance in such a challenging environment. The strategies are diverse, but all are shaped by the need to survive without seasonal cycles of light. The Twilight Zone also teaches us that survival without sun does not mean lifelessness. On the contrary, it may hold more life by weight than the sunlit surface. Trillions of lanternfish alone swarm through these depths, their glowing bodies forming one of the largest populations of vertebrates on the planet. Shrimp, krill, squid, and countless others add to the mass. The absence of sunlight has not made the twilight barren, it has made it ingenious. Life here finds ways to endure in conditions that seem impossible from the perspective of the surface. For humans, this resilience is inspiring. We depend so deeply on sunlight that imagining life without it feels almost unthinkable. Yet here it thrives, demonstrating that biology can adapt to extremes far beyond our comfort. It makes us wonder about possibilities elsewhere in the universe. If Earth's twilight zone can support such abundance without direct sunlight, perhaps oceans beneath the ice of distant moons could do the same, fueled by chemical energy and recycled nutrients. The Twilight Zone is not just a hidden ecosystem of our planet, it is a model for survival beyond it. Imagine yourself drifting there, far from the reach of sunbeams. Around you, fish hang in the dimness, eyes enormous, bodies slender, waiting for food. Lanternfish flicker with dots of light, rising to feed. A dragonfish hovers with its lure glowing faintly red, invisible to all but itself. Jellyfish pulse slowly, transparent bells catching particles as they fall. The water feels empty at first, but then you realize it is full, filled with forms that have turned scarcity into strategy. Survival without sun does not mean silence or emptiness. It means creativity, patience, and endurance. The Twilight Zone shows us that life does not need abundance to thrive. It can build whole worlds on fragments, whole ecosystems on the steady rain of particles drifting down from above. The absence of sunlight has not silenced it. Instead, it has forced it to invent, to glow in the dark, to wait, to rise, to fall, to adapt in ways we can hardly imagine. And as we sink deeper, leaving behind even the last faint traces of light and the commuters that bridge two worlds, we move toward a realm where survival becomes stranger still. Ahead lies darkness so complete that no eye can help, no sun can touch, and the only guides are the adaptations that take life beyond the edge of our understanding. The deeper you go, the more the ocean begins to feel like a place not just unexplored, but unknowable. The Twilight Zone already bends our understanding of life with its pressure, its cold, and its creatures that glow in the dark. Yet even here, where science has uncovered so many secrets, most of what exists remains hidden. It is called the Zone of Mystery not because it is empty, but because it is vast beyond our ability to fully see, a realm so immense that every expedition reveals something unexpected. When sonar first revealed the deep scattering layer, scientists thought they had found the seafloor itself rising and falling with the day. It took years to realize it was life, trillions of creatures migrating up and down daily. That discovery was just the beginning. Every time new nets are lowered, new lights are shone, or new sensors are deployed, the ocean gives up another secret, often in the form of an animal that looks like it belongs in a dream rather than on Earth. Some fish have eyes that rotate inside transparent skulls, others carry lights that flash in complex sequences, and still others appear almost invisible even when illuminated directly. These are not exceptions, they are hints at how little we know of what fills this vast zone. The mystery is partly about scale. The Twilight Zone covers more space than all the land habitats of Earth combined. Forests, deserts, grasslands and tundras together are still smaller than this dim stretch of water. Yet while satellites map forests and hikers cross deserts, the twilight remains largely beyond us. Only a handful of submersibles have travelled here directly, and most of our knowledge comes from nets that damage delicate animals, or sonar that shows shapes, but not details. Imagine trying to understand a rainforest by catching a few birds in a net, or listening to echoes from the canopy. That is the level of detail we have for the Twilight Zone. It is also about fragility. Many Twilight creatures are so delicate that they disintegrate when touched. Their bodies are built of soft tissues, almost gelatinous, designed to withstand pressure, but not handling. When nets bring them up, the pressure difference destroys them before scientists can see their true forms. What little we know comes from rare glimpses in the water itself, through the windows of a submersible or the lens of a remotely operated camera. For every dragonfish or lanternfish that has become familiar to us, there may be dozens more species that vanish before we ever identify them. The mystery extends beyond individual animals to the ecosystem as a whole. We know the Twilight Zone plays a vital role in Earth's carbon cycle, pulling carbon from the atmosphere through plankton blooms and locking it away in the deep. But we do not yet know exactly how much carbon is transported, how long it stays trapped, or how changes at the surface will ripple through the twilight web. Climate change may already be altering these balances, yet we have only begun to measure them. The twilight is not just a mystery of biology, it is a mystery of chemistry, physics, and climate, all woven together. Fisheries add another layer. Lanternfish and other twilight residents may outnumber surface fish by an order of magnitude, forming what could be one of the largest untapped food resources on Earth. Some nations have considered harvesting them on massive scales to feed, growing populations or produce fish meal for agriculture, yet the effects of such harvesting are almost entirely unknown. Removing too many commuters from the daily migration could disrupt surface predators like tuna, seals and whales. It could reduce the carbon pump that stabilises our climate. It could unravel food webs we barely understand. The mystery is not only scientific, it is also ethical and practical. How do we act when we know so little? For the people who have descended into these depths, the sense of mystery is not just intellectual, it is visceral. Submersible pilots describe turning off the lights and seeing nothing but blackness, then suddenly witnessing a flicker of green or blue as an unseen animal drifts past. They describe hearing the creaks of pressure on the hull, feeling the isolation of being hundreds of meters below the nearest sunlight, and realizing that life continues all around them, unseen but constant. The mystery of the Twilight Zone is not only what we cannot study, but also what we cannot fully feel without being there. There are creatures so strange they blur the line between science and imagination. Transparent worms that glow with neon patterns, fish with tubular eyes that collect light like telescopes, shrimp that eject glowing clouds as weapons, jellies that stretch for meters, trailing bioluminescent threads like living chandeliers. Every expedition uncovers forms that seem designed to defy expectations. Some scientists say that the Twilight Zone may hold more undiscovered species than any other habitat on Earth. It is not a place of absence but of abundance, and the mystery is how much of that abundance we have yet to see. Part of what makes this zone mysterious is its invisibility to us on the surface. You can look at a forest and see its trees, or at a desert and see its sands. You can watch a savanna and observe lions chasing zebras. But the Twilight Zone is hidden beneath kilometers of water, its dramas silent and unseen. We know they happen only because of the evidence that drifts upward, or the faint echoes picked up by instruments. The greatest migration in the world happens every night, yet we never notice it from shore. The mystery is not that it is far away, but that it is invisible, occurring right beneath our feet with almost no trace. For all our science, myths and metaphors still cling to the Twilight Zone. Ancient sailors imagined sea monsters rising from the depths. Artists pictured krakens, serpents, and other creatures lurking where sunlight failed. And while we now understand that these legends were exaggerations, the truth is no less strange. The dragonfish, the gulper eel, the viperfish, all look like monsters from another world. Yet they are real, and they are only the beginning. The line between myth and reality blurs in the shadows, where our imagination fills the gaps left by science. Imagine yourself drifting through this zone of mystery. Around you, the water is dim, filled with faint particles of falling snow. Suddenly, a shadow moves, then vanishes. A flash of light pulses, then fades. You sense that life surrounds you, yet you cannot see it clearly. You know that every direction hides creatures waiting, feeding, glowing, drifting, yet the scale is too vast for your senses to grasp. You realise that the mystery is not only about what we have not discovered, but also about what we cannot perceive all at once. The Twilight Zone is too large, too full, too hidden for any single view to capture. The mystery matters because it reminds us of our limits. For all our satellites, sensors and machines, we still live on a planet whose largest habitat is one we barely understand. The Twilight Zone shapes climate, feeds billions, sustains ecosystems from plankton to whales, and yet remains mostly out of sight. To study it is to admit that we are still at the beginning of understanding life on our own world, and to imagine its future is to recognise how fragile that ignorance makes us. As we sink deeper still, beyond the zone of mystery, the ocean grows even darker. The twilight gives way to the midnight, where no trace of sunlight remains, and survival depends entirely on adaptations that seem impossible from the perspective of land. Ahead lies a realm of darkness absolute, where the rules of life are rewritten once more. For as long as people have looked out at the ocean, they have wondered what lies beneath it. The surface can be measured, crossed, mapped, but what waits below the waves has always seemed unreachable. Early sailors imagined monsters because monsters were easier to picture than the unknown. Poets and storytellers filled the gaps with myth. Even scientists armed with ships and nets could only guess at what lived in the Twilight Zone, because whatever they pulled up often arrived mangled or half destroyed. Human curiosity about the deep has always been greater than our ability to satisfy it, and that gap between desire and knowledge has shaped centuries of exploration. The first real glimpses into the Twilight Zone came not from sight but from sound. Sonar, developed in the 20th century, revealed a false seafloor that rose at night and sank again by day. Naval operators thought it was a solid layer, perhaps the bottom itself shifting in ways they did not understand. Only later did scientists realise they were seeing the echoes of fish, squid, and plankton, the entire scattering layer that moves in rhythm with the sun. That discovery alone was enough to transform our view of the ocean. It was no longer a static void, but a living, shifting mass, hiding its secrets in plain sight. As technology improved, nets went deeper, but nets could not tell the whole story. Many twilight creatures are too fragile to survive capture. By the time they reach the surface, the pressure difference has destroyed them, leaving only fragments. Some dissolve into nothing before scientists even see them. Curiosity grew sharper with every failure. What was down there that we could not bring up? How could so much life exist in conditions so alien to us? For every specimen saved in a jar, countless others were lost, and the frustration only deepened the desire to see. Submersibles opened the next door. Small craft, first tethered and then independent, carried human eyes into the depths. Pilots descended through the surface, past the sunlit shallows, into the dim world of the twilight. For the first time, humans could look directly at the animals in their own environment. The experience was unlike any other. Through the windows, the water glowed with sparks of bioluminescence. Schools of lanternfish shimmered in the beams of light, and gelatinous creatures pulsed slowly past, unharmed by the pressure that would have crushed us without the hull. Pilots spoke of the silence, the sense of floating in space, the eerie beauty of being surrounded by stars that moved. Human curiosity had finally met the twilight face to face, and the result was awe. Cameras and remotely operated vehicles expanded this vision. Unlike submersibles, they could stay longer, go deeper, and record what they saw. Slowly, libraries of images built up. Dragonfish with glowing lures, barrel-eye fish with transparent heads, shrimp releasing glowing clouds, jellies stretching into meters-long veils. Each discovery added to the picture of a world that seemed limitless in its creativity. Yet even with cameras, we have seen only fragments. The Twilight Zone is so vast that even after decades of exploration, we have barely skimmed its surface. Every expedition, no matter how brief, brings back species never described before. Our curiosity is fed but never satisfied. This endless stream of discoveries raises new questions faster than it answers old ones. How do these creatures survive with so little food? How do they withstand the crushing pressure? How do their lights work with such precision? What roles do they play in the larger cycle of the planet? Every new image forces us to admit that our knowledge is still small and our understanding partial. The Twilight Zone remains mysterious not because it is empty, but because it is too full, too complex for us to comprehend all at once. Our curiosity is not just scientific, it is also practical. The Twilight Zone holds resources that humans attempted to use. The enormous biomass of lanternfish and other small fish could be harvested for food, fertilizer, or fuel. The carbon cycle it manages could help stabilize our climate if we learn how to enhance it. The bioluminescent chemistry of its creatures could inspire new technologies in medicine and engineering. Every glimpse of its riches makes us wonder what could be done with them. But curiosity has a double edge. To use these resources without understanding them risks breaking systems we depend on. Scientists warn that large-scale fishing in the Twilight Zone could destabilize surface ecosystems, starve whales and tuna, and weaken the carbon pump that locks carbon in the deep. Our curiosity must be tempered with caution, because we are still far from grasping the whole picture. Yet the pull of curiosity is strong. Students who see images of transparent fish and glowing jellies feel the spark that has driven explorers for centuries. Engineers design new vehicles to dive deeper, stay longer, and disturb less, hoping to witness animals in their natural state without destroying them. Biologists develop sensors to measure carbon flux, migration patterns, and feeding behavior, trying to map the hidden web of life. Curiosity keeps pushing the boundaries of what we can see and know. Every answer only deepens the desire for more. For the people who enter these depths, the experience often becomes personal. They describe feelings of humility, of realizing how small we are compared to the ocean, of being surrounded by life that does not notice us at all. Curiosity brings knowledge, but it also brings perspective. The Twilight Zone is not a place designed for us, yet it is part of our planet, shaping our climate, feeding our fisheries, and reminding us that Earth is larger and stranger than our daily lives reveal. To be curious about it is to be reminded of our connection to it. Imagine yourself inside a submersible, the lights turned off to save power. Outside the window at first, you see nothing but black. Then, slowly, points of light appear. A lanternfish swims past, its body dotted with glowing spots. A jelly drifts, pulsing with soft green. A dragonfish flashes its lure in the distance. The water is not empty at all. It is filled with signals, messages, movements. Your curiosity sharpens as you realize you're surrounded by more life than you can count, most of it unseen until it chooses to glow. You feel the pull of questions you cannot yet answer. What are they signaling? What are they hunting? What are they hiding from? Curiosity becomes not just about collecting data, but about feeling the wonder of being here. Human curiosity has always been strongest at the edges of the known world. We crossed deserts without knowing what was on the other side. We sailed across oceans not knowing if land would ever appear. Now the Twilight Zone is one of those edges, still only partly mapped, still waiting for explorers who will take the risk of descending into the dark. It is one of the last frontiers left on Earth, and it pulls at us because it reminds us that our world is not finished, not fully revealed. The more we learn, the more responsibility comes with our curiosity. To study without care is to harm. To harvest without caution is to deplete. To explore without humility is to lose what we came to see. But if curiosity is paired with respect, it can deepen our understanding not only of the Twilight Zone but of life itself. It shows us that survival takes many forms, that adaptation is endless, that beauty can exist in places without light. It reminds us that we are part of a larger system, one that extends into depths we cannot see, but that affect us all the same. And as our curiosity continues to guide us, we realise that the Twilight Zone is not the end of mystery. Below it lies the abyss, where light is gone entirely and survival depends on strategies even stranger than those we have seen. The twilight has tested our imagination, but the midnight zone will stretch it further still, into realms where even curiosity itself struggles to keep up with reality. Long before sonar, submersibles and cameras reached into the Twilight Zone, people had already filled it with stories. The ocean's surface has always been both a barrier and a mirror. You can stand on the shore, watch waves rolling in, and know that beyond them lies a world you cannot see. That kind of mystery invites imagination, and imagination has never left the deep alone. For sailors, poets, and storytellers, the sea's hidden layers became the birthplace of myths. They saw hints of creatures they could not identify, or they found the remains of animals washed ashore, and from those fragments they built legends of the deep. One of the oldest and most persistent myths is that of sea monsters. Ancient maps often decorated their empty spaces with drawings of serpents, dragons, and giant fish. These were not just artistic flourishes. They reflected a belief that where knowledge ended, danger began. To sail too far into the unknown meant risking an encounter with something enormous, something with teeth or tentacles, something that could rise from the dark and swallow ships whole. The Twilight Zone, hidden just below the reach of light, was a natural home for such fears. Mermaids too belonged to this lineage of myth. Blurred shapes seen in rough seas, the cries of distant animals mistaken for voices, and the human tendency to imagine familiar forms in the unfamiliar combined to produce visions of half-human, half-fish beings. For sailors spending months at sea, the idea of creatures that lived where they could not go, who bridged the world of humans and the world beneath, was both terrifying and comforting. The Twilight Zone, invisible to them but always present below, was the perfect backdrop for such dreams. Legends of the Kraken emerged from northern seas, where fishermen told of tentacled beasts large enough to drag whole vessels under. The stories grew with every telling, but at their core was likely the real presence of giant squid, creatures that do live in twilight waters and beyond. When carcasses washed ashore, their arms stretching meters long, they confirmed what stories had whispered. In truth, the giant squid is elusive, shy, and not the ship crusher of legend. But in the human mind, glimpses and fragments were enough to create monsters. The Twilight Zone's hidden nature meant that every unknown shadow could be amplified into something enormous. Cultures across the world built their own variations of these myths. Polynesian traditions tell of powerful beings dwelling beneath the sea, guardians and monsters alike. Norse legends describe sea serpents coiled around the world, their bodies rising from unseen depths. Japanese folklore includes dragon kings and water spirits, ruling kingdoms beneath the waves. Each culture projected its fears and hopes into the ocean, and the Twilight Zone served as the stage because it was both close and unreachable. You could not see into it, but you knew it was there, stretching endlessly downward. Myths also reflected awe, not just fear. The deep was not only home to monsters, but also to wisdom. Some traditions describe the sea as a place where souls travelled, where mysteries of life and death were hidden. The twilight, caught between light and total darkness, became a metaphor for thresholds, for transitions, for states in between. Just as dusk on land marks the passage from day to night, the twilight beneath the sea symbolized the passage between the known and the unknown, the living and the beyond. Even today, myths linger around the Twilight Zone, shaped by films, literature, and popular imagination. Creatures of the deep still inspire horror stories, alien comparisons, and speculative fiction. The dragonfish, the gulper eel, the anglerfish, when shown in photographs or documentaries, often appear so strange that people doubt they are real. They look like the monsters that myths predicted. In a sense, the myths were accurate in spirit, if not in detail. The ocean did contain creatures unlike anything on land, with teeth, lights, and bodies shaped by pressures we cannot survive. What people imagined was exaggerated, but it was not entirely wrong. Our myths reveal more about ourselves than about the ocean. The monsters we invented reflected our fears of the unknown, our sense of smallness before vast forces, our anxieties about journeys into dangerous territory. The mermaids and sea spirits reflected our desire for connection, our hope that even the most alien places might contain beings like us. Myths filled the gaps where knowledge could not reach, and they gave meaning to the silence beneath the waves. But myths also served a practical purpose. By warning of monsters, they discouraged reckless voyages into dangerous seas. By speaking of gods and guardians, they encouraged respect for the ocean. They may not have been scientifically accurate, but they carried truths about the risks of the sea. Even now, those lessons remain. The Twilight Zone is not filled with krakens waiting to crush ships, but it is fragile, delicate, and easily disrupted. Respecting it remains as important today as it was in myth. If you imagine yourself standing on the deck of a ship centuries ago, staring out at endless water, you might begin to understand why myths flourished. Night falls, the waves turn dark, and the horizon vanishes. You know that beneath you lies a world you cannot see. Every groan of the ship, every splash in the distance, every glimmer of phosphorescent plankton feels like a signal from that hidden realm. Your mind fills the silence with creatures, some terrifying, some wondrous, all imagined because the truth is out of reach. That feeling, more than the details of any legend, is the heart of the myths of the deep. Now that we have submersibles and cameras, myths have not vanished. They have shifted. We no longer draw sea serpents on maps, but we watch documentaries of dragonfish and still feel the same mix of fear and wonder. We no longer speak of mermaids as fact, but we still write stories of undersea kingdoms. Our technology has given us sharper images, but the Twilight Zone remains so vast and so hidden that mystery endures. Myths were never only about ignorance, they were also about imagination, and imagination still finds plenty of room in the shadows. And as we continue deeper, past the twilight and toward the midnight zone, the myths grow only stronger. What lies beyond the last traces of light? What forms has life taken in places where sunlight has never reached? The myths of the deep may have begun with guesses and fears, but they continue because the ocean still withholds more secrets than it reveals. There is a point where the Twilight Zone finally gives way to something else. The dim blue haze that still hints at a surface far above begins to fade until it disappears completely. At first, the change feels gradual. The light thins, the particles of snow grow sparser. The creatures with large eyes and glowing camouflage appear less often. But then the change becomes absolute. The last photon of sunlight is lost, and what stretches beneath is darkness without end. This is the border with the abyss, the threshold between two worlds, where the twilight concludes and midnight begins. For animals living here, the transition is more than symbolic. It marks a shift in conditions so extreme that many twilight species cannot pass beyond. The eyes that are so useful higher up lose their function in true darkness. The camouflage that relies on faint blue light no longer works. Even the migration patterns that carry trillions of creatures upward each night usually stop here. Few commuters dare to cross the line into the abyss, because there is no advantage to venturing where light cannot reach, and food is even scarcer. This boundary is not drawn on any map, but it is written into the lives of every creature that inhabits it. Scientists place this border at around 1,000 meters below the surface, though the exact depth can vary depending on the clarity of the water and the strength of the sun above. In the clearest seas, traces of light might linger a little deeper, while in murkier waters the twilight ends sooner. But somewhere around that depth, all natural light is gone, and the abyssal world takes over. For those who cross it, survival depends on a new set of strategies, and for those who stay above it, the abyss is a frontier never breached. The border is also a place of encounter. Twilight animals that stray downward sometimes meet creatures of the abyss, and the contrast is striking. Lanternfish and bristlemouths, with their shimmering dots of light, drift near beings adapted to total darkness, with reduced eyes or none at all. Dragonfish, skilled hunters in dimness, face abyssal predators that rely more on smell and vibration than on sight. For a moment the two worlds overlap, but it is clear that each is shaped by its own rules. The border is not a wall, but it is a divide. For humans, this threshold has always carried weight. The Twilight Zone is mysterious enough, but it still carries echoes of the surface, a trace of light, a reminder of day and night, a connection to cycles we understand. The abyss, by contrast, feels alien. It is the largest environment on Earth and yet the least accessible. When we picture it, we see nothing but blackness, pressure, and silence. To descend past the twilight into the abyss is to leave behind any familiar reference. It is to step off the edge of a world we know and into one we can only imagine. Yet the border itself is alive with subtle transitions. Marine snow continues to fall, but the pieces that reach this depth are larger and more clumped, because smaller fragments have already been consumed above. The animals here are fewer, but they are larger or stranger, adapted to endure long waits between meals. Some twilight predators hover near the border, catching whatever drifts upward or downward, while abyssal creatures rise occasionally to meet them. It is not a sharp line, but a zone of blending, a twilight fading into midnight, a place where two ecosystems meet without fully merging. The pressure here is immense, hundreds of times greater than at the surface. Every centimetre of a creature's body feels the weight of tons of water pressing down. Humans would not survive an instant without thick metal walls around us. Yet for the animals that live here, this pressure is normal, even necessary. Their bodies are built of flexible tissues without rigid air pockets preventing collapse. Enzymes in their cells are shaped to function under crushing force. For them, the border with the abyss is not frightening but simply home. The mystery is ours, not theirs. From the perspective of exploration, this border has always marked a turning point. Most submersibles and cameras linger in the Twilight Zone, where light and life are still abundant. To cross into the abyss requires more endurance, more power, more patience. The descent becomes slower, the discoveries rarer, but also more startling. When explorers first captured footage of giant squid, it was at depths near this border where twilight hunters give way to abyssal giants. To witness such moments is to realise that the myths of old were rooted in truth. Beyond the twilight, the creatures do become larger, stranger, and more elusive. The border is also important in the flow of Earth systems. The carbon carried down by marine snow often crosses into the abyss here, where it may remain for centuries. The Twilight Zone recycles and consumes much of it, but what escapes becomes part of the deep ocean storehouse, locked away from the atmosphere. This transfer is one of the planet's most vital processes, stabilising climate in ways we still do not fully understand. The border with the abyss is not only a threshold of light, but also a threshold of global significance, where the fate of carbon, nutrients and energy is decided. For the creatures that rise and fall daily, the border is as far as they go. The commuters ascend toward the surface at night, feeding in the shallows, then descend again into the safety of twilight by day. But they stop here, at the edge of midnight. To cross further would be to enter a realm where their adaptations no longer function. They remain children of twilight, tied to the faint traces of light that linger above. The abyss belongs to others, creatures born in total darkness. The border is where their paths diverge. Imagine yourself floating there, at a depth where no sunbeam can follow. Above, faint glows of lanternfish shimmer as they prepare to rise. Below, shadows stretch into endless black. Around you, particles drift downward, silent snow on a journey that will never end. A dragonfish hovers nearby, its lure glowing faintly red. Far beneath, something vast stirs, unseen but felt. You realise that you're poised between two worlds, one dim, one dark, one still connected to the surface, the other cut off entirely. The border with the abyss is not just a depth, it is a feeling, a realisation of how fragile our knowledge is compared to the immensity of what remains unknown. For centuries, humans have placed borders on maps, lines that separate nations, territories, or realms of influence. But this border is not drawn by us. It is set by physics, by the reach of light and the limits of sight. To cross it is to step into a realm that has existed since Earth's oceans formed, unchanged and unobserved. It humbles us to realise that such a border exists not on distant planets, but on our own world, only a short distance below where we sail, fish and swim. And as we think about crossing it, curiosity sharpens once more. What lies beyond, in the abyss? How do creatures live with no trace of light? What giants, what hunters, what hidden webs of life await in the dark? The Twilight has shown us ingenuity, adaptation, and survival at the edge of visibility. The abyss promises something even more radical. Life where visibility is gone entirely. The border is not an end but a beginning, a doorway into the deepest mysteries of the sea. When we think about climate, we usually picture skies, forests, factories, or fields. We imagine the air above us, the heat of the sun, the patterns of wind and rain. Rarely do we think of the deep ocean, let alone the twilight zone hidden far below the waves. Yet this dim stretch of water is woven tightly into the threads of Earth's climate, binding together surface life and atmospheric cycles in ways both subtle and immense. To ignore the twilight zone is to miss one of the planet's most important regulators, a system that has been stabilizing our world for millions of years. At the heart of this role is carbon. Every breath we take, every fire we light, every machine we run feeds carbon dioxide into the atmosphere. On land, plants absorb some of it through photosynthesis, but most of the work of balancing it falls to the ocean. At the surface, plankton bloom in sunlight, pulling in carbon and turning it into living tissue. Some of this energy feeds fish, whales and other creatures at the top of the chain, but a large portion does not stay at the surface. It drifts downward in the form of marine snow, sinking into the twilight zone and beyond. In this way, the twilight acts as a bridge, carrying carbon from the atmosphere into the deep sea, where it can remain for centuries. The scale of this process is staggering. Each year, billions of tons of carbon sink into the twilight zone. Some of it is eaten and recycled, rising again toward the surface as predators exhale or release waste. But a significant portion continues to fall, crossing the border into the abyss. Once there, it may stay locked away for hundreds or even thousands of years, removed from the atmosphere and its cycles of warming. This biological pump, as scientists call it, is one of Earth's greatest defences against runaway climate change. Without it, the atmosphere would hold far more carbon and the planet would be far hotter. But the process is not automatic. It depends on the delicate rhythms of twilight life. Lanternfish and other commuters, by feeding at the surface and releasing waste at depth, accelerate the transfer of carbon downward. Krill and shrimp do the same. Larger predators depend on them, shaping their populations and movements. If any part of this web changes, the entire pump could slow, trapping less carbon in the deep and leaving more in the air. The Twilight Zone is not just a hidden world. It is part of the climate system we rely on, even if we never see it. This makes human activity a potential threat. Overfishing in the Twilight Zone could remove huge numbers of lanternfish, bristlemouths, or krill, disrupting not only food chains but also the carbon cycle. Harvesting these creatures for animal feed or fertilizer might seem attractive given their numbers, but their ecological role is immense. Taking them out could weaken the pump, leaving more carbon in the atmosphere, speeding the very warming that already threatens the oceans. Curiosity about the Twilight's resources must be balanced with caution, because tampering with its threads could unravel climate stability itself. Warming seas also pose risks. As surface waters heat, plankton blooms shift in size and timing. This changes the supply of marine snow, altering how much food and carbon reach the twilight. Some areas may see less snow, starving deep ecosystems. Others may see irregular bursts, disrupting established rhythms. Migration patterns tied to light and temperature may no longer align with food supplies. These mismatches ripple through the web, changing not just who eats whom, but also how much carbon sinks or floats. Climate change reshapes the twilight, and in turn, the twilight shapes climate. Acidification adds another layer. As oceans absorb more carbon dioxide, their chemistry changes, making it harder for organisms to build shells and skeletons. Some of the particles that form marine snow depend on these shells. If fewer sink intact, less carbon may be carried into the depths. The twilight could become less effective as a conveyor, allowing more carbon to linger near the surface. What seems like a distant chemical shift is, in fact, a direct thread in the fabric of the climate system. The Twilight Zone also influences climate through heat storage. Oceans absorb much of the excess heat from the atmosphere, spreading it through currents that reach into the deep. The twilight is a layer where mixing occurs, where heat is transferred downward and redistributed around the globe. This moderates temperatures on land, buffering us from extremes. Without the twilight's capacity to absorb and spread heat, climate swings would be sharper, storms more intense, and seasons less stable. Its role as a silent regulator is not obvious, but it is constant. For scientists, understanding these threads is a challenge. Measuring carbon flux in the twilight requires sensitive instruments that can track particles sinking over days or weeks. Following commuting fish demands sonar and tagging technologies that are still developing. Predicting how warming will alter these processes requires models that connect biology, chemistry, and physics on scales larger than any laboratory. Yet the effort is crucial, because the twilight may hold some of the answers to managing climate change. Protecting its systems could preserve the pump that keeps carbon balanced. Disrupting them could accelerate warming beyond our ability to control. For explorers, there is also a sense of wonder in realizing how hidden this influence is. You can look at a forest and understand how trees absorb carbon. You can see grasslands and picture their cycles of growth and decay. But you cannot look at the ocean and see the twilight working. Its role is invisible, its processes unfolding in silence beneath kilometers of water. It is humbling to know that our climate stability rests on a place we rarely think about, on creatures we will never meet, on snow we will never see falling. Imagine yourself floating in the twilight, surrounded by drifting particles. Each flake you see carries a fragment of carbon, captured from sunlight above. Some are intercepted by fish, eaten and recycled. Others sink past, slipping into the abyss. Around you, lanternfish flicker with light, rising and falling in their daily commute. Shrimp dart, squid hover, dragonfish wait in the shadows. Every movement, every meal, every breath contributes to the flow of carbon downward. You realize that the air you breathe on land, the climate you experience each season, is tied to this hidden dance. The threads of climate stretch from the atmosphere to the sea and down into this dim corridor, binding surface and depth into one system. This connection also holds lessons for the future. If we protect the Twilight, we protect not only its creatures but also the climate threads that sustain us. If we harvest recklessly or pollute carelessly, we weaken those threads and risk unravelling patterns that have held for millennia. The Twilight Zone reminds us that climate is not just about weather above our heads, but about life far below our sight. Its role is not optional. It is essential. As we leave this thought, the threads continue to stretch downward and outward, linking Twilight to abyss, ocean to atmosphere, past to future. And as we drift further into the narrative of this hidden world, we realise that the Twilight is not only science, it is also metaphor, a mirror for our own resilience and balance. Ahead lies reflection, the turning of this hidden dusk into meaning for ourselves, a way to carry its lessons back into our own daily twilight. You've travelled far now, from the surface where sunlight glitters across waves, down through the dim blue haze of the twilight, past drifting lanternfish and glowing jellies, through the silent hunters and the endless rain of snow, to the very border where the abyss begins. Along the way, you've seen how life adapts when light fails, how survival continues even where warmth and clarity vanish, and how the balance of this hidden world threads itself back into your own. The Twilight Zone is not simply a distant ecosystem. It is a living dusk, a realm that sustains you without your ever noticing, a place whose lessons linger long after the descent is done. It is worth pausing on what those lessons are. The first is that life thrives in scarcity. On land, we think of abundance as the natural state. Fields full of crops, forests dense with leaves, rivers teeming with fish. In the twilight, abundance is rare. Food arrives slowly, energy is rationed carefully, and waste is recycled endlessly. Yet in this apparent scarcity, life flourishes in staggering numbers. Lanternfish swarm in trillions. Shrimp, squid, and bristlemouths crowd the dim water. Bioluminescent signals flash constantly, proof that life is not merely surviving but communicating, competing, and connecting. The Twilight teaches us that even when resources are few, creativity and patience can sustain whole worlds. The second lesson is that invisibility can be a form of strength. On land, we are drawn to what stands out. The brightest plumage, the loudest call, the most visible display. In the twilight, standing out is dangerous. Safety comes from blending in, from vanishing into the dimness, from mastering camouflage so perfectly that predators swim past without noticing. Here, transparency, reflection, and subtle glows are the strategies that protect. It reminds us that visibility is not always power, that sometimes survival depends on knowing when to be quiet, when to fade, when to let the world pass by. The third lesson is that connections matter more than isolation. The twilight is not self-sufficient. It depends on the rain of marine snow from the surface, on the daily migrations of commuters, on the exchange of energy up and down through the water column. It is not a closed world, but a link between two realms, the bright surface and the dark abyss. Its health shapes both. The same is true of us. No community, no nation, no system survives alone. The threads between us, invisible though they may seem, are what carry energy, stability, and resilience. The fourth lesson is humility. For all our technology, the twilight remains mostly unknown. Every expedition reveals new species, new behaviours, new mysteries. For every dragonfish we have studied, there are countless others still unseen. For every cycle of carbon we measure, there are countless interactions we do not yet understand. The twilight is larger than forests, deserts, and grasslands combined, yet we know only fragments of it. To live on a planet where such vast mystery remains is a reminder that our knowledge is never complete. Humility is not a weakness, but a recognition of reality, an acceptance that curiosity must be paired with patience and care. And perhaps the deepest lesson is one of perspective. On the surface, We move through days filled with noise, light and urgency. We measure time in hours, crowd our lives with tasks, and forget that the planet itself moves in rhythms older and slower than we notice. The Twilight Zone does not hurry. Its commuters rise and fall each night, steady as the tide. Its snow drifts endlessly downward, flake by flake. Its predators wait in silence, conserving energy until the right moment comes. To sit with these rhythms, even in imagination, is to feel the weight of time differently. It is to be reminded that not everything must be rushed, that endurance and patience can be more powerful than speed. Imagine yourself returning now, rising slowly toward the surface. The water around you grows lighter, the blue deepens, the silhouettes of commuters drift upward with you. Marine snow still falls, each particle carrying the memory of sunlight. Lanternfish flicker briefly, then fade. Dragonfish and viperfish retreat into shadows. The chill begins to soften, the pressure eases and the glow above brightens. Soon the surface appears, a rippling ceiling between two worlds. You break through, and the air greets you again. Behind you lies the vastness of twilight, still there, still alive, still unseen. Ahead of you is the familiar world of day and night, of land and sky, of warmth and sound. Yet you carry with you the quiet of the deep, the memory of a place where dusk never ends. This is the gift of closing reflections, to return, but not unchanged. You know now that beneath every patch of ocean lies a hidden dusk that governs the balance of climate, sustains countless species, and holds mysteries beyond our grasp. You know that myths were not entirely wrong, that strange creatures do inhabit those depths, stranger even than imagination allowed. You know that human curiosity continues to descend, that every new glimpse uncovers another question. You know that the Twilight Zone is not separate from you, but part of the same earth that feeds you, shelters you, and shapes your future. Perhaps tonight, as you close your eyes, you will remember the commuters rising silently through the water, the glowing trails of bioluminescent sparks, the steady fall of marine snow. Perhaps you will picture the dragonfish with its red lure, invisible to all but itself, or the barrelly fish gazing upward through a transparent dome. Perhaps you will feel the weight of all that unseen life, moving, feeding, glowing, waiting, in the greatest habitat on the planet. And perhaps with that image the noise of the surface world will feel a little quieter, the rush of daily life a little slower, the night around you a little deeper. The Twilight Zone is not just a story about the ocean. It is a mirror for our own twilight moments. The pauses between tasks, the transitions between day and night, the quiet spaces where reflection grows. It teaches us that even in dimness, life endures, adapts, and flourishes. It shows us that scarcity can breed resilience, that invisibility can be protection, that connections hold worlds together, and that mystery is not an absence but a gift. And so, as this journey closes, it does not end. The Twilight Zone continues beneath the waves, unseen yet constant, a living dusk that binds ocean and atmosphere, myth and science, curiosity and humility. You return to the surface, but the memory of that hidden realm stays with you, a thread woven quietly into your own story, as steady and enduring as the falling snow of the sea.